Hello, my name is Alexander Pliskin. I'm a software engineer with 3 years experience working in development and financial companies, including blockchain sphere. This course name is How to create a supply chain dApp for the order accounting. We will create a supply chain dApp over the Ethereum blockchain using Solidity language for smart contract development, Terraform framework for smart contract management, and testing with Ganesh Klee. Also, we will create a wrapper for interception with smart contracts using modern JavaScript frameworks. We'll have some sessions. We will prepare the environment for the development on the Ubuntu Linux, Mac OS, and Windows. Then we will start the development part. We will use Remix Online IDE for smart contracts creation. Then we will manage smart contracts using Terraform framework. And then, using Terraform, we'll create tests for the smart contracts. After that, we'll create a wrapper for the interception with the smart contracts. Here it is. Hello everyone, this is our first session. In this session, we will prepare the environment for our future work. This is the first session of our tutorials how to create a supply chain dApp for order accounting. The plan for that session is to prepare the programming environment for different OS systems. First, we will prepare the environment for Linux Ubuntu. After that, we will prepare it for Mac OS X, and lastly, for Windows. We will prepare the environment for each system. We will start with installing Node.js stable version 8.12.0 with npm for it, for package management. After that, we will install Terraform framework. Terraform framework is a tool which will help us to develop, manage, and test smart contracts. After that, we will install Ganesh Klee. Ganesh Klee is a wonderful tool that will help us with creating local blockchain for fast interactions with smart contracts. And after that, we will check the performance of all the installation. Firstly, we will prepare the environment for the Ubuntu system. This is Ubuntu 18. It is currently a stable version, and we'll work with it. So let us open terminal. Then, this is a clean Ubuntu, that's why we don't have got any node or npm on it yet. Let us check it. npm command not found. We'll just first install npm with sudo apt install npm command. Let us accept all the dependencies. Okay, here it is. npm current npm version is 3.5.2 and node version is 8.7.0, but we want to use another version. We will use currently stable version. It is 8.12.0. For that, we will do next things. We will install a tool which will manage the node versions. For that, we will install the npm package which is named n. We'll install it using sudo. Now n is installed. Let us see. So now we can select any any of these versions. And let's just check for currently stable version. So we need to use sudo. So okay, sudo and stable. Okay, now maybe we download it. So let's just sudo n. Okay, now we see that here are versions which we can select from. Let us select currently stable version. It is 8.12.0. So we've selected it. Then if we tap node to know the version of our company node, we will see that this is not this one, but we will close the terminal. Then open the terminal one more time, and now enter node version. We will see that it is 8.12.0, this version which we will need, and npm version is 641. It is okay for us. So now we want to install Truffle. We do it with npm install -g Truffle. So you can see there are some problems here. Okay, I know why they are so. We should use for each npm command with g flag sudo. Let's just use sudo. Okay, so now we can see that the Truffle was installed. Let's check it. Truffle flag version. Okay, now we see there some commands, some its commands. Well, then the next tool which we will need to install is Ganeshcli. So let us open the web browser. Let us enter Truffle framework Ganesh. So let us go to the website. Then we're here. You can see that this Ganeshcli site, and we can see that how does it look, and we can see here any documentation for our future needs. What is it? And maybe it will be helpful for us in future. So let us just download Linux version. So let us save file. Now wait for its downloading. So now we can see that installation, the downloading was completed. Then now just let's go to download. You can see Ganesh image. Let us go to properties, permissions, allow executing files. And this file is a program. Then let us write just yeah. So now we can see that we opened it. Let us just continue, and our current blockchain, so a local blockchain with Ganeshcli, is ready now. So it is working, and we will use it in future. Also, well, let us go back to terminal. we install Ganesh GUI, and also we will need to install Ganesh CLI. This is a console client for interacting with Ganesh local blockchain. We'll install it using sudo npm install -g Ganesh CLI. So now it's ready, we have installed it. So now let us, for me, I will create the direction for the workspace. Let's go to this workspace. And now we will check the performance of everything we've installed. So to check that everything is okay, we'll use the default project, Truffle. Let us use Truffle. Let's use Truffle unbox metacoin. So it was downloaded. Now let us see, we can see some directions here, contracts, for smart contract migrations, tests. Let's go to contracts, see that there are some contracts there. Go to migrations, there are also some migrations there. Go out of it, go to test. Okay, and tests. Okay, now. Also, what about the truffle? We can see, let us show the configs. Truffle config, there are nothing there. So there is something there, and we can indeed, so there are not anything default. So, and let us see what is in truffle.js. The same. Okay. Now let us first just check that we can compile small contracts. Let us type truffle compile. So we can see that now the directory is built with compiled smart contracts. So here it is. So you should have the same directory with compiled smart contracts. So now we can say that it's ready, and then we can go to there is no need anymore with this default project. So for that, let us go back and remove it. Okay. So now let us prepare the environment for the Mac OS X. There are two ways. How can we do it? Firstly is to use the terminal, and the second one, I think it's more comfortable for us now, is to visit the official website. Here it is, and just click this button and download the Node version A12.0. Then show it for us, open it, and here to go one by one and install it. I use Mac OS X system, and I've already installed it, so that's why now we'll install Ganesh CLI and Ganesh GUI. So firstly, let us install Ganesh CLI, npm install flag-g. Let us do it with sudo npm install flag-g. Ganeshkli. So Ganeshkli was successfully installed. Then also we need to install Truffle, sudo npm install fg Truffle. Truffle was also successfully installed, and now let us download Ganesh GUI. So let us visit Truffle Framework official website. Here it is, Truffle Framework. Here we can see docs for any Truffle project, Truffle Ganesh Drizzle. So it maybe will be useful for us in future. But now let us download Ganesh GUI. So let us go here and just click that button. So now let us wait, it will be downloaded. Okay, successfully. Let us just open it. Move it to applications. So successfully moved there. So let us now type Ganesh. Let us open it. So you can see now our local blockchain is ready for our future needs. We will use Truffle tests to test it with a local Ganesh blockchain. So now it's ready and we have verified it, and let us now verify that the Truffle framework is also ready to init the project. So where's me? Let me go to my desktop. So here, let me create a folder with the name of the project, which we'll use to verify the Truffle framework installation. Move inside it, and now we can use Truffle and box. And box is a command to get the box with the already created project. In future tutorials, we will init our own projects. Now let us just see what is it and verify that we can work with the smart contracts. Truffle add box metacoin. So it was downloaded. So let us go inside it. We can see some directories, contracts, migrations, tests, and 2 config files. So now let us go inside the contracts, see that there are some contracts there, and go to the migrations. There are 2 migration files there. Then let's go to the test directory. There are some tests there. Okay, it's fine. So now let us use Truffle to compile contracts. We should type Truffle compile. So now we can see that new directory was created. The build directory, let's go inside it. We can see another directory inside it, so let's go there, and we can see now that our smart contract was successfully compiled. So now we are ready for future work. So now we will prepare the environment for the Windows. Firstly, let us download Node.js from the official site. Let us go to the official site, and there we should download this version 8.12.0 LTC. Just let us save it and wait for the download to finish. Okay, it was successfully downloaded. So let's open the folder and let us install Node.js. Or just next, accept the terms in the license agreement. Next, where to save it. Okay. So this runtime. Okay. And then install. Okay, Node.js has been successfully installed. Let us go to the command line now and to verify it. Node is V. The node is installed with this version, yep, and npm is 641, so it's nice for us. So what should we do then? Okay, it's fine, but now we need to open command line as an administrator. Run as administrator. What we will do now? Firstly, we will install Truffle using npm install flag Truffle. Okay, Truffle was successfully installed. This was the first step. Then next we'll install Ganesh CLI. The same way. npm I minus flag G Ganesh CLI. Okay, Ganesh CLI also was successfully installed. So let us now install Ganesh GUI. So for that, I will the Truffle framework official site is blocked in my country. That's fine. I will use VPN extension to download it. So let me switch it on. Truffle framework. So here, let me find, here say, Ganesh, one-click blockchain, personal blockchain for Ethereum development. So here, this is an official Truffle framework site, and here we can also find any documentation for any framework which we will use, and maybe it will help us in future. So now let us download Ganesh GUI software. Let me say Ganesh, and now here just let us go to see what other versions can we find. We'll go to the GitHub. Here we can see all the OS, different versions of Ganesh for different OS operation systems, but we'll download the version for the Microsoft Windows. So let us click on it. Now we can see it is downloading. So now the Ganesh GUI setup was successfully downloaded. Let us install it. Let us go to the folder, Ganesh setup. And next, install. So it was installed. Now let us verify that it was successfully installed. Let us finish with run Ganesh. Analysis enable, okay, continue. So it works. Now we can see that our local blockchain is ready, and so that's fine. So let us now check the performance that Truffle framework is also ready to start to develop. That we are ready to start to develop using Truffle framework. So Ganesh is ready, so we can close it. We can close other applications. So we're here now. So let me create a new folder and name it as let's name it as a project which we will use to refer the Truffle MetaCoin. Well, now, so let me now go to this directory. So now I'm here. So now we'll use Truffle, and Truffle has got boxes. This is such a project which will box it, and we can unbox them and to work with them as with Truffle projects. Well, now let us do it. Truffle unbox MetaCoin. So now let us see MetaCoin. What's here? Contracts, migrations, test, license, Truffle config. We can see that in this folder, the contracts, there will be our contracts. Currently here, there are some contracts for the MetaCoin projects. There are migrations to migrate the small contracts, and test for a directory with tests. So now let's just verify it. We will compile contracts and we'll see that it will be fine. Truffle compile. Okay, Truffle compile. Now we can see that there is an error here, so let us in this case try Truffle cmd compile. Well, now it's fine. So who use Windows? You should use not Truffle but truffle.cmd and then the commands. In this case it will be fine. So now let us go to the directory. Now we can see a new directory build, what is inside its contracts, and here the JSON files, the contracts which were built, which were compiled. So now the environment is ready for future development. Hello everyone, this is our second session of the project How to create a supply chain dApp for the order accounting. This is the second session of the project How to create a supply chain dApp for order accounting. In this session, we'll talk about the future dApp high-level design, architecture, and about a supply chain. So let us start. Let us start from the definition. What is supply chain? Supply chain is a system of organizations, people, activities, information, and resources involved in moving a product or service from supplier to customer. Who are the members of the supply chain? Of course, they can be any other members, not only three which are on the screen now, but without the three, the system won't be a supply chain. So, the first one is a supplier. Supplier is an organization or a shop or online shop or a post office which have got orders which should be ordered to the final customer. The second one is a delivery company. Delivery company get the order from the supplier, and then the main task of it is to deliver the order to the final customer. And of course the customer. The customer is an individual person who wants to get his order from the supplier. What about the supply chain flow? In this picture, we can see different actions which can happen in the supply chain. All three members are participants of this flow. Everything starts with the supplier. The supplier has to initialize the order. Then, supplier transfers the order to the shipping company. When shipping company got the order, it starts delivering it to the final customer. And when the delivery company delivered it to the customer got it, and then he can accept or decline the order. This is the whole supply chain flow, the whole flow of the order. What about the dApp design and architecture? So, it will consist only of two services. The first one is a smart contract, it is on the right, and the second one is an API for interaction with the smart contract, it is on the left side. As it was discussed on the previous slide, each member have got his own actions, and each action is a transaction which will be produced in the blockchain, and information about this transaction will be stored in the memory of the smart contract. And API is a wrapper to interact with the smart contract. Obviously, not each person can work with the blockchain. That's why for every dApp, we need to create a wrapper, an API or a UI or something else for interaction. Using API, we can create transactions and store information about them in the memory of the smart contract. And also, using API, we can get the information from the smart contract. And this will be the architecture of our dApp. We'll create a smart contract, and this smart contract will have got each row from the previous slide, and each row will produce transactions. After that, we'll create the wrapper. which will interact with the smart contract. Hello everyone, this is the third session of our project, How to Create a Supply Chain dApp for the Order Accounting. In this session, we'll create the smart contract. As for the smart contract development tool, we will use Remix Online IDE. Then, what about the smart contract structure? Our smart contract structure will contain methods, the actions of different members, and fields to store orders information. In this session, we'll create the smart contract for the supply chain dApp. So let us go to the Remix Ethereum org. This is the online Remix IDE. Here on this page, we can see the default smart contract. It is a ballot smart contract. What else can we see here? Here another smart contract. Here this is the test smart contract for the ballot. Then here is the console. Here we will see some logs about the transactions, about the transactions which will deploy the smart contract. And here we can use some other utilities to work with the smart contract. Then on the right side, here we can see some tabs. The first one is a tab, compile tab. Here we can select the compile version. Then also we can set the after compile here to compile the smart contract each time when we change something here. Then enable optimization to optimize our smart contract or after the compilation. In this case, when we'll set up it to enable, we'll spend less amount of Ethereum for the deployment because the size of the compiled smart contract will be less. And here we'll use the last stable version. Currently it is 0425. Let us use this one. Here we can select the smart contracts which we want to work with, and here some warnings, errors, and so on. So the next type is a run tab. Here we can select an account which we want to work with. Also we can select here the node which we want to work with. We can select JavaScript VM. It is the VM which is injected inside the Remix. Then we can select injected with. This will be a MetaMask. And Web3 provider. Here we can select any node which we want to connect with. So here's also gas limit, value. Well, here we can select the smart contract, so we can deploy it with some parameters in the constructor, or find the smart contract by its address, and to here we will see it then. So there are some other tabs here for analysis, testing, debugging, some settings. We can change the theme. Somebody would like to work with a light theme, somebody with a dark theme. For the Remix, I prefer light theme. So in the support chat, if you have got any questions about the work of the Remix or Solidity or something else, you can tap your message here and wait for the answer. So let us now start. We don't need these default smart contracts, that's why we will just delete them. So let us now create our smart contract. It will be named by supply chain. So firstly, what we need to do is to set up a Solidity version with pragma Solidity 0425. Then let us now create a smart contract supply chain. So now first let us create a structure for the order. struct order, and what should be inside it? Firstly, of course, maybe a title of the order, what is it? Then the next one will be the some description about the order. Then an address of the supplier who initialized the order. Supplier, then the address of the delivery company, then address of the customer, and finally I think we should have something like a status, but status, it is an enumerable value, so it should be an enum. So let us first say that it will be something like status. Now, so we can see that there is an error, there is no identifier or something identifier not found or not unique about the status. Yes, it's so because there is no such a type currently, but let us create an enum status with some status inside it. So, well, the status, let it be created. Then the next one is when the delivery company got it, it will be delivering. When it will be delivered to the customer, delivered. And then customer can accept or accept, that's why it will be accepted or declined, so declined. So now there is an error. Well, there's no need in the semicolon here. So this is the structure for our order. So let us go to the actions. Well, what should we do? Firstly, we should initialize the order. Function, let us name it as create order. Create order will be public. Well, so let us firstly start with the arguments of that function. So what should be first? The first should be a title. Then the next one is a description. Then the address of the supplier will be the address of the message sender. So we can pass it, and then we should give as an argument the address of the delivery company. So after that, address of the customer. And lastly, the status, but status will be created because it is order creation. So now can we see it is public? Well, so what should we do? We should create an order. To pass all the parameters there. So first name, title. After that, description. Then the supplier. Supplier will be the message sender. After that, delivery company. After that, customer. And finally, status. The status will be status, it is in none, created. So now it should be in memory. So the status is ready now. The memory, because it is just not in the storage of the smart contract, it is just currently tempo variable. Yep. So then we create an order, but we should store different orders. Let us create a field for that. The field will be named by it will be an array of orders. Orders. Well, and it should be public because we need to interact after this with that variable call some values. And what can we do here? We can do orders. Then we should increase the length of the orders. So let us do orders length +1. And then it should be assigned to order. Well, now it's fine. So the first function is ready. Then after that, after the order is, when the order was created, after that it should go to the delivery company. So in this case, let us create a function, start delivering order by its index. Start delivering order, then an index, and in the previous function we can not only create a new order, we can also return its index. So in this case, let us just create new unit, index +1. So here should be index, lastly we should return that index. And here we can pass the index as an argument, and it should be public. Here should be, it is not on by, it is returns, and the type of int 256. Then here we can pass an index. What's then? So we, the delivering company, want to start delivering process. So now we should get the order from the storage. After that, we should change its status to status delivering. So here it is. But in this case, it will be so anybody can get this order and change the status to delivering. But we want that only the delivering company of this order be able to start delivering it. So here we should create a modifier, only order delivering, only order delivering company. And here should we pass index. So let us now create a modifier for that. Only delivering company as a param index. So here we should require that orders index delete company should be equal to the message sender, and then we should pass. And the type of the index is unit 256. So now the modifier is fine. So this method is fine too. Then what should go then? When the delivery company delivered it to the customer, it should change the status to delivered. So let us create a new function. Stop delivering order. Then here we can pass in index of the order, public, and only, of course, here only order delivery company can do that. Here we should also get the order, and then change its status to status delivered. Order status delivered. Order. So now it's fine. So here are the first two functions. What should go then? Well, then the customer can accept or decline the order. He can accept it if everything is fine, and if something is not good for him, or the order was broken or something else, any disease can happen with it, so in this case he can decline it. Well, in this case, let us create two functions. Well, I think also here we should add not only these modifiers, because only can start be delivering when it was just created. So here we can, let us firstly remake old functions and then continue to the customer. Only order delivery company can work with the order, but also the delivery company can start to work with it only if its status is created. So let us do now next things. Let us add new modifier, order created. And also pass the index here. So let's not. Well, modifier, order created, pass here the argument, the index of the order. Then next we should require that the orders, this order, take it by index, that its status is equal to status created. And let us now, so now it's fine. Create not only such a modifier, let us create modifiers for different steps of the order in the supply chain. So here order created. Then let us just copy it. Let us now create order delivering, status delivering. Then the next one is order delivered. Well, I think that's it. So now we have got different modifiers for the security of the order inside the supply chain. So in this case, this was a function when order starts delivering. It can start delivering only when it was created. After that, the delivery company can stop delivering it only when it's delivering it. So here we can set order delivering its index. Then what's next after that? Function. Function. Here we can continue to the functions for the customer. Customer can accept the order by its index. So it should be also public. And here only customer can make something. Only customer can accept or decline the order. So let's just set up here only customer. Also the index. And only when it was delivered. Order was delivered. So we currently haven't got such a modifier that only customer can make something with it. So let us create it here. So modifier only customer So here we should require that this order customer is a message sender. So it's fine now. So now we should accept the order. Well, we just can take the order by its index, then go to its status and set up it as accepted. And the same to decline. So function decline order provide its index here. Public here also only customer. Then only when the order was delivered, only this status we can change. And here orders, not we, but the customer. So status, set up it as status declined. Well, now I think all the functions are ready. This is the smart contract for the supply chain. So now let us deploy our smart contract, and then let us just execute some of the transactions. What do we need for that? Firstly, we will do it using MetaMask. MetaMask is an extension for Chrome browser and also for, as I know, Mozilla browser to store your accounts, Ethereum accounts there. So I've already installed MetaMask. Well, if you don't have it, so you just need to tap MetaMask extension for Chrome or for Firefox, or maybe there are them for Opera or some other browsers. But as I know, this exists for Chrome and Mozilla. So now here we need to go to the store, and here it is. You just need to download it from here. So after that, you can go to the Run tab in Remix. Then here you can see now that there is no account. I don't have them bought. It is so because, well, I should enter the password here. So we will work in the Robson network. So let me just first change the language. Well, so now it's fine. So this is my MetaMask with some accounts here. So I've got plenty of them. So let me just now create new account and name it as a, well, let it be the supplier. Well, supplier. Else in future we'll need the account for the delivery company and the customer. Let us create them right now. So create account delivery company. And lastly, customer. So what else? Then I need to say that we will need some Ethereum on the account. Currently we haven't got it on these 3 accounts, so you can just transfer it from other your accounts in the Robson network if you have got them, if you don't have got them. So in this case, you need to visit the Robson Ethereum faucet, something like that. So let's be faucet MetaMask IO. Should go here, and here we can request 1 Ethereum from the faucet. It will be enough for, I think, for everything. So let us request it here to the customer. So here's the transaction. Let us see. So it is pending now. So let us just wait to receive it. So it was included, so now it's fine. We can close it. I think that will be enough for us. So customer have got 1 Ethereum, so we can send some part of it to another account. So let us just for that select from here. You can see here plenty of accounts, but let us select now the supplier. So let me just find it. Well, maybe it can be in the top. Oh, it was. So here's the supplier. Let me copy address. Then now go to the customer and send to this address. Well, let me send. Oh, it's 38 ha. So 33. Okay, the gas price. So I can make it. Okay, let's be so. Well, no data. Next. Okay, confirm it. Well, and we cannot change the account and then to find it and copy. We can just enter here the name of somebody who want to send to. Oh, maybe it's not so. So let me find. Oh, I see. So we can just find it here. So here you can see the delivery company. Let me send such an amount of fiat rate. So now the accounts are ready. So let me change the account to the supplier. So I've changed it. So here in the remix we can see that here's that account. So, and we can select the smart contracts. Currently I have got only one of it. Maybe in future we'll have got some more. So let us just select it, and after that deploy. Here we can change the gas fee, but currently, so I don't think that we need more. So here it is, confirm it. Now we can see the transaction with the creation of our smart contract. So now we can see that the smart contract was successfully deployed. Let us go and see it. So from this account to here is the smart contract address. So here it is. Well, we can also verify it. Yep, here's the code. Let us just copy it. Then let us see that we used 0425 compiler version, and we set up the enable optimization for tool. So supply chain. Here we should enter the name of the smart contract. Then let us select the compiler version which we use. It was this one, 425 stable version, and optimized, yes. So now just copy the source of the smart contract here. Well, now here's the caption. So, and now we should verify. Processing takes not more than 30 seconds. So the smart contract was verified successfully. So now let us now go to see. So here you can see that this the source of that. Here now we can read. So you can see the array of orders. We can tap any index and see if there is something here. So, and we can write something inside it. So now, okay, here it is. Well, we in summary, I should say that we created a smart contract and we deployed it using MetaMask to the Robson network. Now we're ready for next steps. Well, now I think we have got some problems with the smart contract with the function create order. So let us just try to, there is no need in that index, it needs incrementation. So we can just remove it here. And I think there is no need in returning the index. Let us do it a little bit another way. So here we can just push new order to the orders. Well, now, and I think orders can be not public here. And for that I think we can create another method. So another view method to get orders length. So in this case we will get the number of all orders which we have. So it should be public view, and here we should and it should public view returns uint256, and here now we can return the orders length. Turns. So, and another getter to get the order by its index. Get order as a parameter here. Let's just pass index. Well, it will be public view, and it will return us, well, what if we will to return order, just to return structure. So we know that this type is not supported. So this pragma, well, let us in this case return something else. Let us, oh, I see, we can just return not it, but we can return here a tuple of all the types of order parameters. So it can be string, it can be this, it can be, so the next one is also string, then address, one more time, also address. Well, we can also return the status, but I think we can't return here and yes, but I think we can return an enum, but it will be returned not such a value to return its index inside it. Okay, now we can make, so let us firstly order. So it can be an order from the storage, but also it can be, we can store it in the memory of that function. So let us get order, orders index. Well, and now we can return one by one, order title, order description, then order supplier, after that order delivery company, then order customer, and lastly order status. So now it's fine. You can just make something like that to beautify it. Well, now I think it's fine. So we've updated our smart contracts. So and now we need to deploy it. So let me, here's a customer. So let me just select the supplier. Then let me clean it, everything here. So I think now we can deploy. Confirm it. So now we can see that it was successfully deployed. Let us go forward to the smart contracts. Then let us verify the code. So I can say that in your case, if you've done everything the same way and use the same compiler and set the optimization to yes, so maybe it will be verified, because if you deploy the same contract and Etherscan can see that such a contract was already deployed, it will verify your contract. So now can I copy the source, paste it here, capture here, and now we can verify it. So it was successfully verified. Let's go here, and now we can see it is okay. So we can copy the address of the smart contract. Let's go here. So let us find it by its address. Well, now we're ready to create the first order. So let the sprite be the any bookshop. So the title will be books, and the description. In the description, we can pass the name of any book. Let it be dictionary. And now we need two addresses: the address of the delivery company and the address of the customer. We should go to the MetaMask. Here we need to find the delivery company, copy the address, then paste it here. And now do the same for the customer. Customer, copy, paste. Okay, transact. Well, so it is very low. I can say you that sometimes new UI of the MetaMask can wrongly estimate the value of the gas limit. Well, so I think it is not enough for it. We can just try to see if it is so. So let me confirm it. Transact. Go to this transaction. I think it will be failed because of the gas limit. So let us see if it really will be so. So I can see that it takes more time than usually. Maybe my prediction about it that there will be gas limit error is really so. Yes, really, so much time for the transaction in the ops and testnet. I think there really are some problems. Oh yes, now I can see out of gas. So there are two variants how to solve it. So the first one is we can try here in the MetaMask. We can go to the settings and try to use old UI. It can help us. But we can still use the new UI well and try to make the transaction one more time. But we can increase the amount of gas. So let us go to the edit and just set the 0 here. So now let us confirm and try to see what will happen. So here's a new transaction with the upper gas limit. This Oh, so fast. Yes, now it's fine. You can see it took such an amount of gas. It is, I can say, 7 times more than the MetaMask predicted for us. So when we can decode the input data, see that books, dictionary, key to addresses of the delivery customer. So now let us return to the remix. Here we can get quarters length, so what it is 0, get order, well, no information about the order. Okay, and what if we'll go here to the contract? Well, it's code, we'll try to read it now. So here we can see that orders length is 1 here, and we can get the first order. So maybe, so we can see the result. But here we can see that orders length was increased. I think here are some problems currently with the remix or EtherScan, but no problems with the EtherScan because EtherScan cannot view us maybe these params. But we can see that the length of orders was increased, but here's some problems with remix. But I can say that the order was created. So the response is complex, that's why the EtherScan can tell us something this way. So all the way, let us try here to change the MetaMask to the old UI. Use old UI here. So yes, it's fine. Let us copy the address for the smart contract. Update this page. So it's fine. Well, supply chain, as I see. Go to its address, find it by address. So the same now. So, but, well, let us summarize for this session that we've created and updated the smart contracts. We deployed it to the Lobster, we've created a first transaction, we created a new order, and we can see the exchange on the EtherScan. But there are some problems which occurred with the remix. So I think in the next session we'll see the fix of that. So I think in the next session we'll see that it will be fixed and we'll go forward. Hello everyone. This is the fourth session of the project How to create a supply chain dApp for order accounting. On the last session, we've created a smart contract for our dApp, and then we tested it, we deployed it in the Robson test network. After that, we tried to test it, but we have got some problems with it. So why were these problems? So these days, a new functionality called Metropolis is being introduced into the Ethereum test network. Due to the fact that not all the network miners switched to a new consensus algorithm, there were problems with its work. So for this reason, we were unable to verify the performance of our contracts in the remix.
Perhaps at the time of viewing these sessions you will not have such a problem. However, it's a good experience for us to make it clear that things may not go so smoothly in a test network, as can be some work in it, or the algorithm of the consensus may be broken. Therefore, in this session, we will use the Remix internal environment for deploying and testing a smart contract. We will use injected VM. Also, in this session, we will add something to our smart contract, and according to its results, we will have a ready-made smart contract for our dApp. So in this session, we will continue working with the smart contract, which we created on the last session. But today we will use not injected v3 because of the problems I described to you. We'll work with the JavaScript VM. So in the JavaScript VM, we can find here 5 different accounts with some amount of Ethereum here. So 100 Ethereum for each account. So let the first one be the supplier, the second one the delivery company, and the third one the customer. So, and now, firstly, let us just deploy this contract here and make some tests with it. So here it is, supply chain. You can see that after compile and optimization, everything is fine. Just select these checkboxes if they are not selected on your screen. So now we will select this compiled version 0425 as last time. So now let us use the first account to deploy the smart contract. So, and you can see here it is deploying much more faster than in the Robson. Well, the smart contract was deployed now. There are some debugs here. Well, then now let us make all the actions. So we had a customer was an online bookshop. So the title will be books, then the description, dictionary, and lastly, let us select here. The second one is the address of the delivery company. Just copy paste it here. And the third one is the address of the customer. And then we should go back to the supplier's account here. And now we can transact. So successfully. Here's some debug logs. Well, and now, let us get the orders line. So there is one order here. Let us enter the 0th order, get this order. So, and here, now we can see that the first order contains books, dictionary inside it. Oh, I have got a mistake here, dictionary, so the dictionary. Well, then the address of the supplier, delivery company, and the customer, and here's the value of its status, the 0 status. Here it is created. So now it's fine. So then, after that, only the delivery company, which delivers the order, can start delivering it. If we will try to execute this function with the current account of the supplier, we will reach an error. Let us just try it. So here we know that the index is 0. Let us pass 0 here and press the button start delivering order. Well, we can see there is an error here. So, and as I said, it is because only the delivery company can start delivering it. So if we'll change now to the account of the delivery company and now try to execute it one more time, let us press start delivering order. Well, now we started delivering the order. And if we will check the order now, so let us just now press get order, we can see that the last field of the order, its status, was changed to from 0 to 1. The 0 was created and the 1 is delivering. So now the status of the order is delivering. So what then? Then I think what can be? Well, if the customer now wants to decline the order, so he can't do that because the order is delivering now. So let us try to execute it. Let us select the customer account, close this tab. So let us now decline the order with the index 0. So if we'll try to do that, so here we can see a log with error, so the transaction was reverted. Well, so because now only the delivery company can make something with the order, but not something, it can finish delivering the order. So let us now remove some values here. So let the delivery company stop delivering order. So successfully. Now let us check the order, get order, and here we can see that its status was changed to second, the second, 0, the first, the second is delivered. Well, and now only the customer, only the customer can accept or decline it. So now we have got the account of the delivery company. If we want to just accept the order by the customer, or well, if there were some problems with the order during its delivery and the delivery company wants to make something for the customer, let us try it, accept the order. Or we can see now that the transaction was reverted. So, and now if we will switch to the customer account and accept the order, so it's fine. And if we'll check the status, the status now is the first value. So 0, first, second, third, accepted. And if now, after the exception, when they accept the order by the customer, he wants to decline it, we also will find that he can't do that. So if we tap, so there is an error. The error because the customer can decline the order only after, only when its status is delivered. So now we tested everything of our smart contract, and it is nice, but what else can we add here? So to start with, for each action, we can add an event. Event is something like a log inside the smart contracts. So if you see here now, there are some, in each transaction, there are something, there's an output here. So we can see its status, well, its hash, then who transacted, where, to whom, well, the gas, the transaction cost, execution cost, the hash of the transaction, one more time, input parameters, decoded input parameters, well, decoded output, what the transaction returned to us, then something about logs. Now here there's nothing about it, and the value which we can change here if we want to execute the payable function. But in our case we haven't got payable functions, so what is logs? If we want to log that the action, as for example, when the order was created, we want to create a log, something like order created, and to if any member want to know about it, he can just subscribe to the events of the smart contract and see them. So let us now create such an events. So now orders, so on. Well, now let us create event. Firstly, we'll create the event for when the order was created. So event order created. So, and what about the params? I think the first param should be the index of that order, and also this parameter should be indexed so that we can subscribe to the any index. And but maybe I think it shouldn't be indexed, so just an index. Well, so compile index. Well, what's next? Spectator. So it's inside it. So now it's fine. Well, now the index and I think some index params. So who should know that the order was created? I think there should be two more fields here. The address of the delivery company, and it should be indexed. Well, and the address of the customer. Well, and the same I think we need to create for all other actions. Let us do it. Well, let us create the event order delivering. Well, let us first create it. So we should also type here index, and after that the address should be indexed of the supplier and the address of the customer, for them to know that, for supplier to know that the order which they created is now delivering, and for the customer to know that his order started to delivering to him. Well, next event order delivered. Here I think should be the same params. Well, then the event when the order was. Oh, here we can create two events: order declined or order accepted, or one that order came, that the customer got the order, and we can pass here the parameter about the result. So what will be better? I think it is better to create here two events with different names to see different logs, not to go inside the params. So, well, yes, let us create two events. Order accepted. Here should be the same index and two addresses: indexed address of the supplier and the address of the delivery company, and nearly the same, but with a different name, different semantic. Order declined. So in here we should pass the same params. So now we created all the events. So, well, now let us go to all the actions, all the functions, not callable functions. Well, here, create order. So order pushed, and then we should emit the event that order. So we can just before the push emit that the new order was created. So yes, because we need to get the index, so let us orders length. Then the second parameter is the address of the delivery company. And the last one is the address of the customer. So here. So when the order will be created, we'll emit an event that order was created. So when the order starts delivering, so here we can, before changing the status, emit the event that the order delivering, then pass the index here, then the address of the supplier, and lastly the address of the customer. And nearly the same one when the order was delivered, so when it stopped delivering order. But there is another one, so not here, order delivered. Then for the accept and for the decline, we should emit the event that the order accepted. Then here index, order the supplier, then order delivery company. Let me just firstly check that if it's fine. So supply delivery company, it's fine. Supply delivery company. So and here, yes, let us firstly copy this string that we need to get this order. The order for n, now it's fine, and the same here. So firstly order, and then let us emit the event order was declined with params index order supplier and order delivery company. So now it's fine. We've updated our smart contract and it is fine now, but it is fine if we know the index. How to be if we don't know anything about indexes? Of course, one way is to subscribe to the events, and when the new event came, then we can see the index and know that this sub-index, and using it we can see how this history of our order. But what if we don't want to subscribe? So for that reason we can also create mapping here, mapping which will be, the key will be the address and the value will be array of indexes for this address. So, and we will name it order indexes. If any member of the supply chain want to know about indexes of orders which he created or which he needs to deliver or which he wants to get, he can just see by his address, get values from this mapping and see the indexes of his orders. So it should be public now, order indexes, and letters in each action, or maybe not in each, only in the first action when we create the order. Here we can just after pushing it, we can just create next one. We can get order indexes. Then, firstly, message sender is a supplier, and push the index. The index is order. So let us create index param. Index orders length. Well, here we'll change to this index, and here we can push it. So here now we pushed it. So and here we push it only for the supplier, but now let us push it for all other members. So who are the delivery company, push index, and what index it is, and customer. Here also index. And then now any member can not only subscribe, and then after subscription, well, we should save the index somewhere, but now we can save it inside the smart contract. So each member can now just read this value, this mapping, and find all the indexes of his orders. So well, now it's fine. So I think we can now, we don't need our smart contract. So let us now select the supplier, and here clear the console output. So let us make it bigger. Let us deploy new smart contract. So it was successfully deployed now. So let us now do all the supply chain flow for each member. So first thing, let us create the order. So the same books, then dictionary, then address of the delivery company. After that, the address of the customer. So let us select here the supplier account, and now we can transact. So it's fine. And let us see now. Now we can see a log here. So what about the log? Who created the hash event that order was created? So now here the params that was created order with such an index. Then we can see that this address of the delivery company, this address of the customer. So it is correct. And then let us here firstly check the order's length. It is right. Then get the first order. So it's fine too. And here, this mapping, now we can go here. So first, let's select the address of the delivery company. Well, the result is fine. So let us now create another order. We will name it not books, but cars. The same supplier, the same customer, same delivery company. In description, let us type Tesla. So now let us create it. So it was created. We can check the order. Cars, Tesla, the same people here. So same members. So the order strength was increased, and it will now. So here we can see, because we created a mapping with address to array, we need to pass here two params. So in this case, let's just make some changes. So we want to return the whole array. Well, let us now. Firstly, I think it is better to change the name of this parameter, not order indexes, but self orders. Then in this case, we should change. So here, yes, not self orders. Well, this we should start with, and then we need one more view function. Function get self orders length. Public view returns u256, and then here we can return letters to self orders, then find it by the message sender, and then length. So now it's fine. In this case, we will know the length of all the orders we have, and then one by one we can, when we get the self orders, we can get by the address and by the index. So I think now it's fine. For that, let us just, so let us remove this. So now select the supplier, okay. Deploy new contract. Well, now let us create new order, books, then the description, dictionary, and address of the delivery company. After that, the address of the customer. So here we should switch back to the supplier. Well, now we can transact. Okay, we've created it. So here we can see now logs. So they're fine. Well, let us create the second order, but let us select as a supplier the fifth address. So the fifth account from here. So he'll be the supplier, then the delivery company will be the fourth one. So the same customer, and the title will be cars, and the description, let it be Tesla. Wait an order. Well, here's the next debug log. So here are the logs. Here we can see an address of the customer, then address of the delivery company. Also here we can see the new index. So, well, now let us switch to the customer. And so firstly, let us find the number of all the orders. There are 2 orders at all. And what about the orders of the customer? There are also 2 because he have got 2 orders responding with his name. Well, now let's now copy his address. So, and let us now find the first one. So it is with index. Its index is 0, and the second one index is 1. So if we will now go to the order and take by its indexes, here's the first order with the books, with the dictionary, and if we'll tap here the next index, so let us see cards, this one. So now it's fine. And if we would like to check, as for example, the orders with this supplier. So firstly, let us close it now. Get self-orders length. So get self-orders length. Okay, maybe it's true. Well, let us type. Error encoding. So we have got some errors with encodings. So for that reason, let us just clear it here. So now let us select. Yes, because it is not string. So select the first supplier. Call 7 here. Well, now, so close it. So get orders length. Yes, it's true. Get self orders length. Okay, it's true. Well, let us now get the self. So copy an address, self orders of the supplier. 0, 1 is 0. Then 1 is also 0. So only zeros. So, and if we'll go here and get order by 0 index, so you can see books dictionary. And let us select this delivery company. Let us copy now its address. So delivery company, as far as I remember. Well, get orders rank. And now if we'll get self orders. So yes, the outpost is 2. So why is it so? Maybe because here the self orders. And when we create the order, where is that function? Create order, so supplier and self orders. Push, here pushes. So maybe let us provide here. Yes, I think we need to here to provide all the way the address and find not by message sender by but the address. Self orders by address and length. To be better now. So one more time, clean it here. So let us create everything from the beginning, deploy, well, one by one, create order, books, dictionary, then address of the delivery company, after that address of the customer, address length, so okay, it's fine. Then let me now change this as a supplier, so cars, Tesla, the fourth one is a delivery company, the third one is a customer, transact, yes, fine, transaction is delivery company, okay, get orders length, so if I now check get order 0, here it is, so I can see that, well, oh, I didn't change it, I think, yes, here where it comes, well, one more time. Firstly, with the supplier deploy, we should change it to the supplier, transact, now get orders length, get order 0, so now they're all are different. So after that, the same customer, here cars, then Tesla, lastly delivery company is the fourth one, and the last one is the supplier. So now transact, get orders length, it's increased, so next one, and then they all are different now, so now it's fine. So and now let us check the customer, let us copy it, get self orders length, here the customer address, so two of them, self orders 0, 1. So first we should provide an address, okay, address, then 0, 1, call it 0, okay, it's fine, and 1 is 1, indexes with 0 and 1. If I go here 0, then the customer did the same, it's fine, and 1, customer the same. And if now I will use, the supplier, who was the supplier of 0 order, here his address, so firstly get self address length, only 1, now it's fine, so let me now go self orders, then 0, 1, call 0, so, and like as I can see, so it's fine. So now I can say that this is the final version of our smart contract. In this session we tested it using the injected in the Remix environment, and you can see it was much more faster than waiting for each transaction in the Ropsten. What else? We've added events inside our smart contract to get the logs about all the actions, and also it is possible now for us to subscribe to these events and to see if something happened. We can subscribe if we know the address of the customer we want to subscribe to his events. We can just subscribe to such a type of events. Well, so it's fine now. And also we added a new field inside our smart contracts to see self-order indexes. So if we don't want to subscribe to any events and we want to know all our to know something, so not something, we just want to have got a list of our orders, what should we do in this case? We have got such a field here, self orders. We can know its length. Then go for each index of these self orders, get the index of the order inside the array of orders, and after that get information about any order by its index. Hello everyone, this is the 5th session of the project How to create a supply chain dApp for order accounting. In this session, we'll initialize the truffle project. We'll set up the configuration. After that, we'll create migrations for our smart contract. After that, we'll create tests. Different unit tests for our smart contract to describe every action. So let us start. Firstly, we need to create a directory. You can create it any way you want, and I will create it on the desktop. So here I am now. So let us name it as a supply chain. After that, we should go inside this directory. So there is nothing here now. And here we should initialize the project. We can do it using truffle. So if we want to create a truffle project, we will use truffle. So let us do now truffle init. So now let us see what is here. Here we can see 3 directories with contracts, migrations, tests, and 2 config files. Let us see what inside the contracts. So there is a migration contract there. Okay, and if we go to the migrations, we'll see there that there is a first initial migration there. So, and if we'll go to test, there are no tests there now. So we have successfully created, initialized a new truffle project. So now we can we just need to get our smart contract, which we created in previous sessions, copy it inside the contract, and after that we'll set up firstly the environment, and then after that we will run the Ganesh, and then we will migrate our contract to the Ganesh local blockchain. So now we'll create migration tests, config the truffle.js file. So I prefer using IntelliJ IDEA as a smart IDEA. So if you want, you can use it, or any other IDEA, or any other text editor for this. So the first thing we need to do, well, here we'll create a new file with our smart contract. Let me now paste it here. So here we can see this is our smart contract. Well, after that, let us go to the migrations and see the first initial migration. In the initial migration, we can see that here we import the migration smart contract, and here we just deploy it. So if we'll see the migration smart contract, here we can see that this is a smart contract which will create some transactions with, it will just log all the migrations which we will do. So there is no need to change everything here, because in real, for our project, we won't need it. So let us now go to the migrations and create a new migration file. So the migration file should start with the number. The number should be the next number from the last migration. Here we can see that we have got the first migration, initial. Let us now create the second one and name it as supply chain smart contract, we can name it, but let us just stay with this name, supply chain. Okay, so here we'll create we'll write the JS code. So the first thing we need to do, we need to import the smart contract, supply chain. Here we need to go to the artifacts. The artifact is all our artifacts, and using it we can get the smart contract. And here we should use require, and then the name of our smart contract, supply chain. So we've imported it. Now we should deploy it. So module exports function. Here we need to, as a parameter, deploy. In the deploy, we will deploy our smart contract. So fine, this file now will deploy the smart contract. So now let us configure the network. So here we need to go to truffle.js. There are two files, truffle.js or truffle.config.js. So we can use any of it. Well, let us change that to truffle.js. So here in this configuration, well, let us firstly describe the networks. After that, the first network which we will use is test network. So in here we should provide the host, then port, and after that the network ID. So network ID. So as I said before, we will use Ganesh CLI. So for this case, we should run it. So on the first session, when we prepared the environment, we installed the Ganesh GUI. So let us just run it. Here it is. So we've started it. Here we can see the host, then the port, and the network ID. So let us just use these values. So the host is localhost. The port was 7545, and the network ID. So here we can get this number, but also we can just provide here a regular expression that we can use any network ID, because as you see, Ganesh CLI is the only one So currently it is the only network which is running now on our local host. So now it's fine. We've created the migration, we created the smart contract, we updated the config file. So now we can go to the terminal, see that we're in the right place. So now, firstly, we should compile our smart contract. Just tap truffle compile. And so we can see now an error here. So the source requires different compiler version. So truffle currently use the compiler 0424, but we used 0425 compiler version. Well, to solve it, we can go to the supply chain smart contract and change the Solidity version here to use previously stable Solidity version. This is the first case, so let us try to do it now. So truffle compile. So you can see now everything is right, and we can now see here the build directory with contracts. Let us go inside it. See that here the contract name, it's Abby, it's interface, bytecode, word bytecode, and so on. So we can just change the version of the current used Solidity version for the smart contract. And there is another way how we can not to change it here, but in this case we'll have to upgrade the truffle to the next version, just typing truffle npm style flag g truffle. So it should run it as a sudo. So, and now we can see truffle version, but here we can see that Solidity compiler is also 0424. So in this case, let us try to uninstall truffle. We should run it as a sudo user. So it was uninstalled. And now let us install truffle beta version. It is better currently now, so we can see that if we type truffle version, we can see now that new version and the Solidity compiler is okay for us now. So it is not good that it is better, but it has got the higher version of the Solidity. So let us try to continue with this version and see what will happen. So now I will change back to 0425 in the supply chain. Here I am now. So let me now do truffle compile. So there are some where is me now? So if I pull around it says a sudo, but I don't think that we need it. So you can see now I run it as a sudo user and it is fine now. So now in the contract we can see that it was updated. Let us see. So see it now, it's fine. So we can verify it one more time by deleting this build directory. Well, if we run now truffle sudo truffle compile, so it's fine now. Well, let us go to the build directory, and here we can see that it was successfully compiled. So it's fine. Now we can go forward and migrate our smart contract to the local blockchain, to the Ganesh. So for that, let us do sudo truffle migrate. And for this, let us tap the network. So we can see here, we can see networks tests. So let us just name test networks, network test. Okay, so now we can see some logs here. Let us open it. So we can see that the migration started. So there is one warning here. Okay, so this is information about the network, about the limit of the block gas. So here we can see that the first migration ran and some params about it, and the second migration ran too. So if we will now go to the Ganesh and go to see, here we can see some blocks were created, and we will see transactions. So here we can see 2 transactions were created. So here's the first smart contract. Well, let us now go back and see the second smart contract. This was the second transaction. We can see it starts from these values 6, 08, 06, and so on, and ends with 0029. So if we'll go back to the build contract supply chain, here we can see the bytecode, and it also starts with 608 and so on. And if we'll go to the end of this, it ends with 0029. So it's fine. Our smart contract was successfully deployed to the local blockchain. So, and now we can continue with tests for our supply chain smart contract. So let us go to test and create the first test. Let us name it as supply chain test. Yes. Now let us create our first test. So firstly, we need to import the smart contract. The same one is for the migrations. Well, now let us use supply chain. Let us create tests for it. Contract, its name. Well, so now the first test will create a new order and just verify that it was created with the correct params. So let us name it as number 1, create new order. Well, firstly, we should get the instance of the smart contract. Then, after that, let us firstly prepare the arguments for the order. First one is supplier. Let it be accounts, the 0 account. Then the same for the delivery company. Let it be the first one, and lastly the customer. So here all the members. Then now we have got the title. So let us just add a comment here. Members. Then order parameters. So the first one was a title. Title, let it be the same as we tested, books. Second one, description. Let it be dictionary. Then what else should we pass? So I think that's it. So, and now let us transact. Let us create instance. Then we should create order. So if we'll go to our smart contract, supply chain, here we can see a method, create order, title, description, delivery company, customer. So let us now execute it. So we can close, there's no need in these tabs. Well, create order. So the param should be title, then the description, after that delivery company, and then customer. So here we should first await. After that, as we know now, this will be the first order. So we can now get this order. So we should, for this, execute a method. So get order by its index, get order, instance, get order 0. This will be the order. So, and after that we should check that operands are fine. So let us first check that the order title is fine. So let us check that so it equals the title and the order title. And here should be a message that order, if there will be an error, order title is not correct. Well, now let us test it. Truffle truffle. So we should run it with sudo truffle test. So we can see now that there is an error here. So we can also see that there was an event that order was created with such an index. It's fine, but assert equal is not a function. So if we'll try it with assert equal, and now try one more time. So we can see that it is undefined. So let us just log it. So here we can see that the params are named by they're named by the numbers. So if we'll take not the order, not the title here, but if we'll take, let me take the zero parameter, when run the test one more time. So now it's passed, it's fine. Here we can see also the time which we need to pass it. So now let us just make some changes here. Well, let us check not only the title, but also we will check other parameters. So it should be the second one is a description. It is the order. Then the address of the delivery company. So as we know, the first one of the first parameter of the order is the supplier. So let us first check the supplier. It is order. And also do the same for the delivery company and customer. So, and also have got the fifth one. It is the status equal, and the status. So status is the fifth one. Status not zero in brackets. So let us provide that created. So, and the status will be, as we know, to 0, but we can see here that it is a big number. So let us first try with 0 and see what will happen. Go here, clear it now. Now let us run truffle test. So it's passed, it is fine. So the order was correct correctly. Well, now, then after the next action is that we should start delivering the order. It will be the second test. So also, as we know, these parameters will be the same for all the tests, so we should get them outside the first test here. So now let us, well, firstly we should get the instance. Well, after that we should start delivering order. Let us see the name of this method. Start delivering order. So we should pass its index here. So, and we should execute this function from the delivery company. So we should firstly provide the parameter. As you notice there. So let us also create, well, index here. So order. So we just index this. Order index. Here we should also change it. Order index, then start delivering order by its index. And to send a transaction from the delivery company, we should pass here from and here delivery company. So then after that, let us get the order. And then assert equal. There is no need to assert that all for this program, so let's just assert that the status now will be, the next one is 1, then order 5, status is not 1, delivering. So now it's fine. Let us test one more time. So both the tests passed. So now we can see that the second action method works fine. So now let us create the method to stop delivering order. So it will be nearly the same. So let us just copy this one, paste it here, but now we stop it. So let us see, stop delivering order, stop delivering order, its index, get order. So status is not now 2, delivered. So, and also I think we should create a parent for statuses. let then be status created. After that, status delivered. Then, so delivering first thing, then delivered. After that, accepted. Finally, declined. So in here we'll change here from, so here created. So I think these are constants. Created. Delivering. And now delivered. So let us check it. Sudo truffle test. So it's fine. Then the next step will be, we'll check that the customer accept the order. Get the instance. After that, create the transaction, accept order. So let us check the name. Here it is, accept order. Its index here. And finally from the customer. Because if we'll do it with the delivery, let us check it. Let us tap the delivery company here if delivery company want to accept it. So then let's get the order. So we can just copy it, these two strings. Order, it should be accepted. Order 5. So now we will check it. It should end with an error. So we can see something is not fine here. So the fourth test is failing now. No events were emitted. So customer accepts order, VM exception, we're processing transaction. It was reverted. And it is fine for us because it should be reverted. Because only the customer can accept it. So now if we'll change here from the delivery company to the customer and run it one more time, we will see that now we can pass it. And let us create one more test. Customer can't decline accepted order. Because as we know, if customer had accepted the order, now he can't decline it. Instance. Get the so now we will instance accept So now we should decline order index and do it from the customer. And now we should see that it will be reverted. So let's just now see it. So just type sudo draft test. Oh, we can see here now that there was an error there. So let us in this case fix it. So let us try then catch an error. Well, after that, let us assert recall that the error. So here's the error message. Let us copy that error message will be this one. And now we should the message that expected revert error. So let us try to do it now. Just sudo draft test. Assert this. So yes, there is also here returned error. So let me just add this one here. So and one more time. So now it's passed, so it's fine. So we tested all the actions. Not all, we didn't test the decline action. So let us now test that also we can decline the order. In this case, let us create one more test that customer can decline delivered order. So in this case, we need to create a new order first, and then to make all the other actions. So let us for that just copy some previously wrote strings, lines of code. So first we create the order. So here we'll create a new order. Then after that, we'll start delivering the order. Then we will stop delivering it. And then customer will decline it. And then we'll get the order. But now its index will be not 0, it will be 1, because we've created one more order. And also you can ask me, while for each time we just type here sudo truffle test, we have got the order with the 0. So before each test session, firstly the truffle migrate, doing the migration. so it migrates new contracts, and then do the tests step by step. So now we'll get this order. It will be the next index. So, and now let us assert that who equals that declined is equal to the order status. It is the fifth parameter of it there, and the message is order status is not declined if something will go wrong. So let us now test. So here's the errors. It was reverted. So the order was created. So what's go wrong now? Oh yes, it is reverted because here we should pass new index. So let us just type here order, well, new order index. It is order index +1, and here new order index. Here also new order index, and lastly, so here get this order new order index. So now it's fine. So now everything passed well. So now we tested all the actions. Well, now what should we also test? So if we go to the supply chain, we've tested all the actions. Well, these two. So, but we didn't test it the order length. Then we didn't test it the values of the self orders. So which person and which orders does he have? So for that, let us create tests for that. So the seventh test will be orders length should be 2. So for that, let us also, well, get the instance. Well, then we should call it instance. Well, what do we have? Orders. So not orders, we have got another. So we should get orders length. Instance get orders length, and it is a view function. That's why we'll execute it with a call. So, and it will return us orders number of orders, and we know that it should be 2 orders number, and then let us check it. Assert equal to, so with orders number. So here it is. Let us now test. So it's passed, so it is fine now. Well, the next thing is that now we should check that, what can we check now? We can check that the customer should have 2 orders. For this case, let us just copy this one. And now we should call not get orders length, we should call another function, get self orders length, and provide the address there. So customer should go to orders, get self orders length here, the customer address, customer orders number is not correct. So let's just check it now. Okay, it's fine. And nearly the same we should do also for the supplier. That the supplier should have 2 orders, and the delivery company. Delivery company. So in here we should provide the address of the supplier, and here the address of the customer. So in here supplier and delivery company. Let us firstly create that maybe we can expect that only one order was delivered by this company. We should get an error here. So let us try. So here's an error here that the delivery company number is not correct. Expects 1, but we got 2. So let us fix it. Test one more time. Well, and also this is the 10th test. So we can see now this test passed well too. So we will see our smart contract now. Also, what can we check? We can check that the self orders has got right values. So let's just check it for the customer. Customer should have correct self-order indexes. Well, and then I think here, so we just provide the customer address and the value was also 2, so let's just change here to the delivery company. So now for the customer, for his self-orders, let's just take the instance, the same supply chain deployed. Well, after that, we know that there are just 2 orders that he created, so let's just check here that their values are fine. So set equal. So let us firstly get the order 1 index. Should await that. So here we should get it from the self orders, call it with the address of the customer, and so here's the first, and the second one will be that. So we can just name it not as second, the 0th, and the first. So we'll call them then we'll get indexes, and after that let us assert these two values that the first thing that should be 0, so the second one is 1, then order index 0, then incorrect 0, order index, and for the second one nearly the same, incorrect first order index. So it's final. So let us just test it. Draw for test. So it's final. We've tested not only the actions, we've tested the fields which we created. So now we can see if we really test everything. So yes, we can see. So these were just example tests. Of course, we can create a test. We can use these here accounts and create tests not only for these only 3 members. We can add some more suppliers, some more delivery companies, some more customers, create different other variants. So what else? We can also test that we have got the events we wanted, and with the events with the right values. Then we can test that the safety of the smart contract, that only when the order status created, that only the delivery company can execute it, not supplier, not customer. And the same for the customer, that only he can accept or decline it, not the delivery company, not the supplier. We've just tested it, and that we tried it here. So, but I think that's enough for just testing the actions and the fields. Hi there! This is the session number 6 of the project How to Create a Supply Chain dApp for Order Accounting. In this session, we'll create the backend part of our dApp. We'll create a Node.js project using Express. Well, let us now go forward and let us see why do we need the backend. And firstly, we need to know that where should we store the data, in the storage of the smart contract or in events. So as you remember, we've created some events to log the information about the different order statuses. And also we store just some information about the orders and about its indexes for each member of the supply chain in the fields of the smart contract, and the fields are stored in its storage. So, and I can say you that from the yellow paper that if we want to store 1 byte in the storage, we will need just 20,000 of gas. And if we want to log an event, we just need to pay for it 375 gas and 8 gas for 1 byte. So as for example, let's just take a byte, so 10 bytes message, and see that to store this 10 bytes in the storage, we will need exactly 200,000 of gas, and if we will just log an event, we will just use 455 of gas. So it is sometimes if we not need to interact with some field inside the smart contract, we can just create an event with some information, then subscribe to these events using the WebSocket provider from the Web3, and then to store them in the database and go to the database and get this information, because there is no need to store it in the smart contract. Well, and if we want to get to know any information, we can just go to the smart contract and can get it right from there. So what about our dApp? So we will have got an API which will subscribe to some events and a smart contract which will generate these events. And now let us implement it. So let us initialize the Node.js new project. Well, so on my desktop, I will create, let us name it as a supply chain API, and also I'll move the travel project inside it. Supply chain API as an Ethereum. So here, and also I think there is no need in API, so I just can change its name to simply supply chain. Well, it's nice now, so let me go inside it. Well, now I'll initialize the new Node project, npm init. So the package name is a supply chain. Okay, version, the description will be supply chain API. The entry point. So by default it's index.js, but we'll create another one. No test, no. Okay, it's fine now. So let me see. And what we will need. Of course, we'll need some dependencies. Well, we will, to interact with the Ethereum blockchain, we will need the Web3 library. Web3, so what else? We will need the Express framework to create an API backend. Well, yes, so we need .env to get some environment parameters. And I think we will get the events from the blockchain and then we will store them in the MongoDB. So that's why we'll need Mongoose to interact with it. Well, we didn't install the Mongo on the session where when we were preparing the environment, but we will use not the local MongoDB. We will use a remote MongoDB. We will use cloud server. So I will show it to you a little bit later. So let us first install the dependencies. So Mongoose latest found. Okay, let us first install this one. So the installation of the Web3 can make some can end with some error sometimes on different OS systems. Well, if you use Windows or Linux or Mac, firstly, as I know, we need to have got the C++ or G++ compiler and some Python tools to compile the package. So if you have got some error, the reason can be because of you have got some these utilities. So we can just find the solution in Google. You will install some utilities, and after that you can install the Web3 library. so it takes some time to install it. Well, now we will also install Mongoose. So now it's fine. Well, now we'll create inside it the source directory, and inside it we'll create all the other files for the API. So now we can open the our favorite editor, code editor. So I will use IntelliJ. So here we are. Well, let us create the app.js file. So and here, here we'll prepare the Express framework, and also here firstly we will create the subscriber to the events. So for that we will need Express, so then we'll use Web3, so let us now create the Express. So app Express. Well, I think now, well, we will need, so also we will, to interact with the smart contract, we will need its ABI. ABI is the JSON interface of the smart contract. We will get it from here. So here, Ethereum build contracts. Here you can see it. Migrations. Also supply chain JSON. So I will name it as an ABI and take it. Let us create first inside the source the config directory. We'll store some configs inside it. Directory config. So, and inside config we'll have got the ABI of our smart contract. Let us do it. Supply chain ABI. Well, now let us just copy it, go to the supply chain. Now here's the ABI. So we need just copy it and paste here. So here you can see the ABI of our smart contract. Well, let us require it from the config, and then well, Well, after that, we'll need to connect with the Web3, new Web3. Well, here we need to get the provider, Web3 providers, and we'll need to use the WebSockets provider to be able to subscribe to different events. WebSocket provider. So, and here we will need to get the host and the port of our provider. So let us now in the config file, so we need to create an index config, and inside it, let's adjust now. So we will use .env, that's why we will create an env file and store some params inside it. So, and model. Well, here we will need, so firstly, what about our backend API? So we need port for it. By default, let it be 8080. Then the host, by default, it will be localhost. After that, so maybe host URI. You're right. After that, we'll need the Mongo URI. Well, then the Ethereum RPC to connect to it. And lastly, the address of the smart contract. And then we'll export all these parameters as the port, host URI, after that Mongo URI, then Ethereum RPC, and lastly the address of the smart contract. So it's final, and let us now create inside the supply chain the env.env file with some params, with some environment variables. So let them be Ethereum address. We'll get it after we'll deploy it. So the next one, the Ethereum RPC. So we will use the Ganesh local as a blockchain provider. So let us use localhost, and the port will be 8545. And last, a Mongo URI, and we'll create it and then just paste it here. So now we have got index, we'll get some parameters here, the port and the host are default. So let us go to app.js. Now let us also require the config file and the .env. So firstly, require .env to get the environment variables and config them. After that, so here let me import the config file, the index config. So in this case, I just need to tap config here. Well, then we'll get the ABI, after that WebSocket. So here I just need to get there from the config Ethereum RPC. So then I should prepare the contract, new Web3 Ethereum contract, and provide here ABI and the address from the config. So then after that, let us subscribe to events. We can subscribe to any event. So contract, events, and then let us subscribe first to all events, because as we know, we have a different type of events. Then the order is created, then the order was delivered, then it was accepted or declined. So let us firstly subscribe to all events. Then, well, we should provide the information from which block, from the first block, from block 0, and then if we got any error or event. So let us firstly just log it. So console log. So we can log it on the if error. And log the event here. So I think now we are ready. So here we subscribe to different events, then we create the config. Well, let us now just connect the mongoose. Well, let us create in the config for the mongoose. And mongoose, we need to import the mongoose. And then import the config. So yes, because we need to require here, because we do it inside the config, we need to require index. Well, after that, let us make that mongoose promise. So some preparations to work fine with mongoose. And mongoose connected with, let us get from the config the mongo URI, and we use the mongoose which is higher than 5th version. That's why let us use new parser to. So, and well, now we can export it. So now it's fine. Well, after that, let us also create the bin file to start up the application. So firstly, I will create new bin directory. Well, and then new file. Well, and inside it, so this will be well. I use Unix system. That's why I will tap my the node here this way. So then I need to get the app. After that, I will get the mongoose. Then let me get on the connection. So when I will be connected, function that, well, after that I can only start my express. Firstly connect to Mongo and then start the express. And log that started on port and the port here. So fine, and we'll create function graceful. So then the mongoose connection close. Then just process, let it exit with 0 code. So here process on. So then process area, so graceful. And here sig term singlet. Graceful. So this is the script to start the application. So, well, now we'll prepare the mongoose cloud. So we need just to open the terminal, and here in the terminal let's just tap Ganesh Kli. And now we'll see that the server has started, blockchain server. Here available accounts, available private keys for these accounts, the gas price, the gas limit. So here it's host and the port. We can copy it, but we can see in our end that we've already prepared it. So, and now we can just deploy new smart contract and get its address, paste it here, and then just start listening to any events. So we can use the truffle, well, and also we can do it using the remix. So for this, we need just to go to the remix IDE with our smart contract. There we should go to the run. Here we need to select Web3 provider. And okay, so tap its localhost 8545. It is the default value. So okay. And now you can see there are 10 accounts here. So, and let us just deploy a new supply chain contract for the first account. So copy its address, go back here. So change the env so Ethereum address, Ethereum RPC, Mongo URI. Then now let's just go to the app. Here we'll connect, so WebSocket provider. Connect to the WebSocket of the RPC node. So then get the contract and then listen to all the events and log them. So now we'll start the Node.js Express app using the node daemon. So let us first install it. npm install flag g node daemon. So I think I need to run it with sudo. You can do it also in the terminal, not in the IDE, but please just do it not in the terminal where you've already run the Ganesh. So it was installed, node daemon. So now let us just do a node daemon and then select the bin www.js. So it started, some arrows here, so not all events, all events. Save it now. Let me restart it. So the arrow that this control object have address yet, please set an address first. So some problems with address now. Let's just see. So here Ethereum address here, and in the config we have got so here we have got contract address. So let us just change it in the here. So here contract address, and now we need to restart the node daemon. So now there is with the so no port in the config. Well, so let us go here so we can see config port is here. Well, can't find model source. Yes. So well, we should change it in the www config. No port here, just only config. So now it should work fine. So let's just restart it now. So authentication to Mongo. So maybe the password is not correct. So not the Alex, select user. So, and now restart. Started port on object. So, well, let us just see now. Why is it so? So port is here, then port, host URI. So it's yes, I think because so here's the port. So now you can see started on port 8080. Well, now it's fine. So let me just, so we can see here that we will block any event. Let's just try to do it now. We can go back to Remix. Then he will create a new order. Books, dictionary. Then let's select the second user as the delivery company. The third one will be the customer. And to create, and the first one will be the supplier. So if I will create an order now, let me just transact. So we can see it was transacted. So here's the event. You can see such a block here. And if I will go back here, so here you can see that we looked block index, transaction, the address. So here result. You can see here, this is the index. This is an address of the delivery company, address of the supplier. So delivery company, supplier, and event order created. So now we can So we have subscribed it to all events of our smart contract, and now we'll not only log them out, we will save them to the MongoDB. So to create a new entity and save it inside the MongoDB, firstly we need to create a model with Mongoose. So here we've got in the source directory the config. Also let us create a new one and name it as model. So, and let us make inside it new file and name it as a event. So just an event. Well, and now we'll prepare the new Mongoose entity. So Mongoose, let us firstly import the Mongoose. Well, we'll need the schema of the Mongoose, and well, now we can create the schema for the event schema. Well, and now what should be inside the schema? So it is here should be the same things as in the contract event. So here will be, well, the first one, let it be an index, and its type will be it can be, so let it be something called number, and so let's be just number. So then the second one is a title. So the title of the event, but maybe we can, so as we know, if we go to the Ethereum, to the just contracts, the supply chain, here we can see that inside the order we can see its index and to whom. Well, I think that we can log not only the index and the addresses, we can index some more. So we can just in the events we can modify them and to show something more. So but maybe there is no need currently, so we can just, well, when the order was created or delivered something else, we can, what do we can store, what do we can take? We can log the event and then subscribe to this event and then get the event index and then some index and some parameters. So maybe we can modify our so I think we can modify the events and add in each event add so maybe
So we can store the index, then the information about the customer, to the type string, then need the same about the delivery company, about the supplier, of course, and the event type, so the event status. And in this case, I think we'll need to look in each event not only the addresses of the company. So here we need to look all the addresses. So let us just, in this case, modify the smart contract. And here we can add supplier. So let me take and just paste it in each event. Here and here. Well, and now we'll need to also modify some functions. So we'll need emit events with. So here also should be the supplier and the same arguments for each emit. Let me just copy this. So here, here supplier, then order delivery company. Well, and copy this now and paste it when we stop, when we accept, and when we decline. So now we have got new arguments for each event. Well, in this case, we will need to redeploy the smart contract. And I think our test will go fine because we just changed the events. So, and then let us go back to our model. And here, so then the status. Well, the type will be, it can be string or number. So let's first it be number. So we've created the schema, and now I think we just need to export it. Go to the Mongoose model, its name event, and the schema, event schema. So that's it. And now we'll create the index. So file here to import, so to export the whole models. Currently we've got just only one model, so let's just create an index.js. And here we'll firstly let us get the event. From this directory event, and then we'll export it as an event. So it's fine now. Then let us go to the app. In app, we'll firstly, so we'll get the event. From the model, and there we have got event. So now we can hear when we got the event. Well, let's adjust here.
So let us just create, so from the event, so let us firstly see what can see this event. So JSON parse, firstly parse it, then now let us create a new event. So books dictionary, then address of the delivery company and the customer. Transacted now. Now if we will open, we can see that event, there are some more parameters here. So, and if we go back here, so we can't parse it as in, okay, so maybe in this case, we can firstly JSON. So, and then parse it. What will happen in this case? So now it's fine. And when we parse it, we can get, so the transaction, block hash, block number, address of the smart contract type. So, well, but we need to get, so no return values here. If we'll go look now just the event, oh, I think it's happened so because this is, we get just the old event. So if we'll create one more event, and now see the result. So maybe some nodes, right? So here, look the event. Undefined event. Oh, I think it's so because we didn't change the ABI of our smart contract. Yes, it's really so. We can compile it using truffle, but we can go here and go to the compile. So get the ABI, we copied it. So go here now, delete it and paste new ABI. So now it's fine. So if we'll try it one more time, so now we can see all the parameters here. And if we will, so look the parse event. So here it is now. What about the return values? So return values. So here we can see it, return values, and if we'll get index as for example, it should return yes 1. So now it's fine. So let us firstly we can parse the event. After that we can create values. So let us create const values event, and then here values. So and we will, so if we, let me just try just to console, just to look the values now. What will happen to values index? So it is now undefined. So now we need to, so here we will get the values. Let me just one more time look the event. Values and event name. So here the values and event name and get it by event. And if I will look now values and after that the event name, I will get the event name, it is right. And what about the values? So not the values but return values. Now we can see, so we got all the parameters. And now after that, let us create new event. So event, create. Let us see the event. First, it should be the index. So it will be the event index. So after that, event index, then what about the supplier, event supplier, after that we will need to, so the next one is the delivery company, event delivery company, and finally the customer, not finally, customer, event customer. And then we have got here the status. So let the status be not the number but the string. And what about the status here? The status will be the event, not event name, event status. So using this we will create the event. We can of course wait for it, but let us firstly wait for it. So in this case we will need to make it an async function here. So but I think there is no need because we can just create and then go next. So here not this but values here. Of course, we can a little bit optimize it, but let's just now to test it and see that everything works correctly. So well, now let me just save it. And something happens. So if we'll go to the imlab, see the collections here. Let us update the page now. So we can see that the collection event was created. If we'll go inside it, so we can see that there is an event here. So event with such an index, the delivery company, the customer, the status. I can see the supplier. So supplier, type supplier, string, values. Oh, so we get the just only one p. So in this case, let me just firstly update the smart contract. So where was it? Here it is. Supplier. Now it's fine. So let me now. So delete. So supply chain DB. So let me firstly just remove everything from here. Now I'll need to redeploy it. So let me just now So we can stop, but we cannot stop. Okay, let us go to imlab, delete the collection, go back to the Solidity. So new contract was created, so the title books, after that dictionary, then the addresses of the delivery company and the customer. Now now I can transact. It's fine here. Something I think happened here, and if I go to imlab, update it. So let me go back to the app.js and restart it. So it makes such a look here with event status. Oh yes, it happened so because I need to change the contract address. Let me just copy it now, go here. So for this I will need to restart. So I can see that we have got a log here. If we go to imlab, update it. So collection with the event, good, let's go inside it. So what's now? Now there is notice apart to. Okay. Okay, in this case, let us just see here. Maybe the problem because console log values. It's also 1p here at the same time. So why can't it be so? Because I have redeployed the smart contract, supplier, order creates supplier. If I transact some more times, so I've created so there are some more, so different indexes, and no supplier in any of them. So I know why is it so. This so because the same, so I need to copy the Abbey. And now let me go here, paste new Abbey, and then go to the imlab, delete all documents here. So, and now I need to. So now I've came to an error. Oh, there is because so I need to stop. All the node demons. So I see now, well, if I go to the imlab now, so now it's fine, we can see the supplier, delivery company, the customer. So because we restarted it, we've got only the last event, so let me just now for this create one more, two more, and so on. go to the aim lab. So now we can see that we created some more events here, and we've got information about them, that the order was created. So now it's fine. So we subscribed to the events, and we got the information about them, and we store this information in a database. So in this case, we won't need to store information about the self-orders, and using this we can optimize our smart contract. But let us just stay with this field for to make it easier to debug. But if we'll do something like a ready production version, we could just remove it and use the backend service to get the information about the order indexes from it, and then when you got the index, we can just go get the information from our smart contract. Hi there, this is session number 7 of the project How to Create a Supply Chain Dev for Order Accounting. In this session, we'll update our backend part, we'll add some roads there to get the events, so to make the API, and also we'll optimize the smart contract because currently there is no need to store the information about the indexes for each member. So in this session we'll create the API, but firstly I think so we need to update the Truffle project because we've installed the beta version, but when we initialize it we use the last stable one. So for this, let us first go to our project. Well, but maybe not to our project firstly, but let us first create some sample directory. Then there we will initialize the Truffle project. So here it is, and you can see in the new Truffle, so there is no Truffle.js as a config file, there is only Truffle config.js. Let us see what is inside it. So there are some more fields there, and let us use this one. So here we have got it, Truffle config. Now let us go to our project, go inside the Truffle project there, and there we can, so we have got Truffle config and Truffle.js. Now we can remove Truffle config.js, remove Truffle.js. Well, and now let us move from the template to here. So here is desktop, there's supply chain, there's Ethereum. Okay, now let us see. So we have got it. Got Truffle config.js. Now let me go inside the IntelliJ. Open the supply chain project. Well, now here we can see this Truffle config. So let us not delete all these settings, so because they're commented, let us just, so we will use, previously we named it as a test, let us now name it as a, so for testing we'll use development, let us uncomment it. and here. So just provide the same information. So let us now delete the old compiled smart contracts firstly. So, and now on the last session we've optimized, so we've just updated events. Now we can read the events and store information about the orders, about the indexes for each address in the MongoDB. So let us just make now some optimizations. There is no need currently in the self orders. And in this case, we can, when we create the order, we can just delete self orders, not to do something with it now. So if I will just try to match some, so no need to get self orders length. So now I think it's fine. We've made some optimizations. So let us now make the orders public. Or no, we can just stay this way, get the length and get. So there's also no need in length now. We can just get order. So in this case, let's just now try to compile smart contracts. Truffle compile. So the compilation was run successfully. Now we have got new build file, and also from this build file we can get the Abbey and paste it in the source in the config where we use Abbey, because currently we've got updated Abbey. So what else now? I think now we are ready. So let us now try to make some migrations. Let us for this go back to the console. Here we can start the Ganesh clean. I think so the Ganesh clean is already started. Well, in this case we can now just try to migrate, and the network will be development. So they were successfully migrated. Now let us run tests. We'll get some errors because we've updated our smart contracts. We removed some methods. If we'll now truffle test, so we can see there some of them failed, the 7th, 8th, the 9th, and the 10th. Let us now fix this. So let us go to test, supply chain test. Now we can see that from 7, because here we get the orders rank and there is no need now to get it, so we can just remove it now, because we haven't got such methods. And about this, here's information about the self orders. We can also remove this. So now it's fine. Let us try to test one more time. Truffle test. So it's fine. We've updated our smart contract. Also, if we go to supply chain JSON, well, now I think we deployed it. Yes, and we can get right here. Let us try to find address of the smart contract. So So we can get it not from here, we can get it from the, where had we done it? Here. So we deploy smart contract, account, and here is the contract address. Let us copy it, then go to the env, and here we can just update it. So it's fine now. So we've optimized our smart contract. We've updated the tests, updated their config file. Now we can go to the app.js, and now let us right here create the route. So we'll create the API to get some events by the address. So let's just create app, get the events, then request response. And now firstly we'll get the address from the request query, then we'll name it as address. After that, let us find all the events from the event model. Find, and we need to find, so we'll find if the address corresponds to the supplier or the delivery company or the customer. So we'll use or. Then you should provide an array of queries. So first let it be a supplier, and the same for the delivery company and the customer. So find events. This will be the events we're gonna find, and after that, so we'll send it in the response send events. So it's fine now. Now our app is ready. Let us now test it using Postman. So now let us go to the remix. So here there's no need to import a smart contract. Let's just remove it. Then we'll need to copy a new one. After that, we need to get the address, find contract by its address. So well, now let us go here and delete all documents in collection. So now it's clean. The smart contract was deployed, tested. So now we can, let us firstly start up their application. No demo. So we should go firstly here. So no demo being with WJS. So we've started. Let us go here. We have got the road now. So let us firstly create an event. So create an order. Well, create an order, same books, dictionary, then the address of the delivery company here. After that, the address of the customer, back to the supplier. So it's fine. Now we can transact. Transaction was successfully done. Well, here we can say log. So later we can remove it, so there is no need in this log. If we go to the MLab Mongo Cloud, here we can see, well, a new order created, and now let us go to Postman. Postman is an application, you can download it, just Google it. It is very helpful to test some API. So here in this file, let us just create and get a request. So let us stay with here events, and then we'll provide the address, and the address will be, so let us go to Remix, and if we would like to find it by the customer, his orders, let us just now paste it here, and now send. So no for it. Very interesting. So maybe it is so because, so we need just, so if I'll ignore case, it's no case, I think. So if now we'll try to do it, so now it's fine. So because we can just not, we just need now to make our query ignore the case, and if we'll try to find the customer orders, so let's just paste here the customer address. So here it is. So using this MongoDB, now we can, so we have got an API, and we can get from the the information about we can just tap the address of anyone and just get his orders. So let us just now make it ignore case. So let us go back. So and now, so in the remix, let us also test it. We've created the order with zero index. Let's get it. So here we can see, here it is, books, dictionary, and all addresses. So let us now go back here, and in the query, so the find. So now to ignore the case, let us use instead this query, the regular expression. So just search for mongoose, then use new regular expression. So the start of the word, and this plus the address. Let's just use it to lowercase here. And finally, E. So just so the regular expression, or expect. So okay. Okay, let me first just copy it. Well, and now expecting. Yes, I should just close it. It's fine now. So, but we've got the last event, so to be double in our database. But now, if we'll go back here, so we can see there are two of them now. But if we'll try to use the lowercase now, or any other case, so we'll got it. So now I think our app is ready to get the event. So let's just, so we'll first delete or hold the documents from the mongoose. So firstly, we need to do that. Then we'll deploy a new smart contract, and only after that we'll start up the our service. So let us start it now. Okay, now we can see the last event. So if because there is only one event now. So if we now go to the postman and try it, So there is no matter it is higher case or lowercase. So let us just cc db send. We can see it now. So now our app is ready. Well, of course we can make some optimizations in the API code, but I think it's pretty enough. It's pretty enough for the just such a study project, and we'll use it. We'll use so in future sessions. So we'll create a UI and UI. So using UI, we'll connect to MetaMask and send transactions, create orders, then what else? We'll be able to accept or decline them. Also start delivering it and stop delivering it. Well, what else? So for this, we'll redeploy the smart contract, or maybe we can use just this one. Then we'll start up their app and use the API of this app to interact with it and with smart contracts. So that's it for that session. Hi there, this is the session number 8 of the project How to Create a Supply Chain Tab for Order Accounting. In this session, we will prepare the UI component of our project. We will clone the React Redux template, and then we'll create the functionality to interact with the smart contract. So in this session, we will prepare the UI part of our dApp. So firstly, let us go to the link from the description. This is a React Redux template file. So let us just clone it. I will clone it on the desktop. Okay, it's fine now. Let me rename it firstly from the React Redux template to supply chain UI. Now it's fine. Let me go inside it, supply chain UI. Now let me make some changes with the package.json. So in the package.json, I will first rename the project. So it will be now supply chain app, supply chain UI. The version, let me change it to 1. Private, okay. Author is me. Then I think it's fine now. Well, also for this project, we will need to install. First, let us install all the dependencies from the package.json. So, and also we'll need to install the Web3 to interact with the smart contract and the Ethereum itself. And of course with the MetaMask, because in this session we'll connect our UI to the MetaMask and we'll do all the actions using the MetaMask account. So it takes some time to install the Web3. So it's fine now. Well, let's also see. So there is no need currently in the Git folder. So it's fine now. And now we can open the editor, go to editor. Then after that we'll open the supply chain, and then we'll create some reducers, actions, and so on. So we'll create the UI. Let me open it. There's indexing. So while it's indexing, let us see something inside. What is inside it? So here we've got directory with node modules, some public, some icons here, index file. So then the source with actions, assets, companies, config, constants, and so on. And so firstly, let us just start it. npm run. So let me see the package JSON. So let me npm run start. So into the browser. Now let me open it. Localhost. So here it is. We run it. Now let us make some changes. Let us go to components, containers, main. Here change it from the header to supply chain. After that, let me go to the history. Instead of the user, now we're going to have an account. So name it as an account. Well, so after that, so firstly we need to create a new reducer to store the Web3 instance in the store, in the state. So it will name it as Web3.js. And now, well, firstly we need to import the Web3 from the Web3. After that, let us assign it to the initial state. So the instance will be the new Web3. So we'll use MetaMask. That's why we need to use window Web3 current provider. Well, and now we should export it. Export default function. Provide here that the state equal to initial state and return state. So it's fine now. Let us now go to the index, and here we need to import the Web3 on the Web3 and just export it. So successfully. Then after that, let us go to the index. Here we can see that we have got some views here. Index U is empty. Let us create this. The index U will be the user profile, and create also a route for it. Route path. Then, well, let it be account. So maybe not user profile. Maybe it's better here to name it as an account. Account, yes. So when we'll import account from, well, let it be in components, then views, then account. So there's currently no such component, but we'll create it. So now let us create it. So go to the views, create here new account G6. So, and now, well, we'll create it using the material UI. So let us go back to the browser, go to material UI next. Open it now. See some, so we have got some demo components here. So we'll use a card for it, just such a simple card, show the source. Let us just now copy it. Paste it here. So rename it as an account. And it will be multifunction button class account apps. So extends the React component. Then here's the return, so we need to create a render here. Then, so some properties, something else, there is no need in it. So there is also no need in this. So so what we should so now, well, it should looks like so firstly let us create a component will mount, and here so we'll execute some actions, and in the render so what should be inside the render? We're gonna have got, so first we need to get the props, so const, so firstly classes, get them from the properties. Well, also we need to, so we need to connect it with the Redux, compose with styles, so we'll compose styles, and also we need to connect here. So let us first get so state. The state will connect with, so we'll get the address of the account. And also we will get the information if it is currently loading. Count loading. So, and for the dispatch, we will need to get the address. Well, and for this we'll get it and dispatch get address. So, but currently, so what else here? Export user profile, compose, style, connect. So what's it here? So I think there's no need in this, and here we should close it. So now it's fine. Well, and for this we're gonna need, so the component mount will get from the props and get address. And for this we will need to, so remove this. We'll need to import the compose function. Compose from the util, and also we'll need to import the connect from the React Redux. And also we'll need to import the get action, also get address from actions. Actions from the account actions. So, but currently, so we need to create it. So firstly, let us create some new constants. So they will be account load address, and the second one that was successfully loaded. So and now in the views, so let us go here. So we need to create so firstly let us create the reducer account JS. Well, and to create an account reducer, so we need first to import the reducer factory and also assigning from a libutile. These are just some helpful functions. Then we'll need to import the constants account. So let me go here and change it now. Go back here, count success. And then now, firstly, let us create the initial state. Or maybe we can name it either. Let us name it here default state, and in Web3 let us also change it to just default state. And the account, so default state will be equal to loading. So when we start, we doesn't load anything, and the address, first it will be empty. Then now what about the actions? First action is account load. So here we'll have gotten so state, and in the state we should assign it to state, and so that we started loading true. And the next one is account. It says success, loaded successfully. Is here we're going to have got a state and then address, and then assigning the state, so the address and that's loading. Loading false now. And now we should just export the reducer. So reducer factory, default state, actions. So we should export as default. So now it's fine. So just let's change from double quote to single quote and go to the index, and now also import account from account and paste it here. So now in our state we're gonna have the routing, web3, and the account. So let me just save it all now. Now I need to go to the account. Here I can see that, so now we need to create an action, so we can do it now. Account.js, and here, so firstly we need to import constants, account address and account success. And now we'll need to export the function get address, and from it we'll return the async function with the dispatch and the get state. Firstly, when we start getting the address, we should dispatch that, so account, so we should dispatch the type account log address, and then after it, so it will change the state, and then we should get the web3 from the state, so get state, then web3, then instance, then we will get the address. We need to do it with and wait. Web3, Ethereum, then get accounts. So now he will get different accounts, and then we should, as an address, return 0, 1. So, and then let us just dispatch it. New type is the account or success, and now the address. So we'll dispatch it. Let me save it now. So in the account unexpected, so minus 64. So it's fine now. Let me go back to the browser, to our app. So we can see now that supply chain account and nothing here. So if we will go back, and here instead of the order of the day, instead of it, let us here get the address. Now we have got an address here, so it's fine. And now, so firstly we need to get it from the properties. So now you can see that in some time, so the address was just downloaded, and we can see it here. This is the address of the current MetaMask account. Here you can see it ends with 89 89.6 and here 89.62. So it's fine. And also, so we have got also the property loading. So let us now in the content. So firstly, if loading, then print p, that's this loading. And on the other case, so if it's over here and elsewhere, we'll get this line. Let me go here now, so we can see very fast was here loading, and then we can get the account because we got it really very fast. But then when we'll interact with the API and with the smart contract, then you'll see that we will need some more time. That's why we need such a record loading. So it's fine now. We've connected our UI to the MetaMask. We can go to some information about the account now. Well, now let us go back, and so we'll create some more constants here to interact with the API, and then we'll create for them reducers, actions, and some new views. Then let me just now change the loading here from loading to the circular progress. So for that, let me just first import it. So we'll need import circular progress from material UI core circular progress. So now it works. So let me just save it. Go back to the browser. So we can see that it works so fast that we just see it for a moment now. Okay, so and then now, so firstly let us create the action reducer. So let us create functionality for order creation. So we'll start with constants. Constant, the first one, order creation. And the second one will be then the order creation success. Okay, it's fine now. Then now we'll create a reducer. The reducer for orders. So we'll name it as orders.js. Well, now here, so first let us import the utilities, the constants, then let us create the default state, and actions, and finally we'll export export default reducer factory with the default state and with actions. So what will be the default state? Of course, so when we create new order, we're gonna have got a transaction that we have got this order. So let us save the transaction. Initially it will be null, and that's pending, so pending will be false. And when we're gonna change the location, so we will need to make it now. So let us also import the constant location change from the reactor Redux router. And now we can create actions. So the first one will be when order creation. So we have dot state, and then we should assign to the state that pending is true. Then the second one, order creation success. Here we're gonna have dot state and also the transaction. And then we should assign to the state, assign transaction, and that's pending, now false. And finally, when we change the location, we should set the transaction to null. State. Yes, it's fine now. Well, now let us create, so firstly the dApp. So the dApp in the config here to then interact with the smart contract. So it will be supply chain AB JSON. Well, and here, so let me just go to the supply chain project, then there go to truffle project, go to the build contracts, supply chain. Let me open just now. Here's the dApp. I can just copy it. So go back and paste it here. So this is the dApp of our smart contract. And so after that, I need to go to the config. So in here, so we will need the address of the smart contract. Let us now firstly create React app address. Then here of course we can create an .n file and they provide all these params. So okay, but let us just first test it here and then maybe we'll create it. So the address, React app address, well, and so to add here the address. So for this, let me just, well, start the Ganesh CLI, then so go to the terminal. First I need to start Ganesh. So I can see, so there are some accounts here. Let me just copy them. So and create a file with, so new window. So here I'm gonna have got all these accounts. Well, now we have got these accounts, so we can go back to the code here. So the Ganesh CLI is ready now. So let us first go to the mlab and to our database, and let us just clean it if there is something inside it. After that we'll start up, so run the backend part. So here we can see it is clean. Okay, now let us go back. So let me now so go to the supply chain and there start the backend part. So before I will start it, firstly I need, so before I start it, so let me firstly deploy the smart contract, then get its address. So yes, let me go to the Ethereum here. So let me now make migrate. So truffle migrate. Oh, sorry, truffle. So here we can see that our smart contract was deployed. So let us get its address. Yes, here it is. Go first to here, to our UI, paste it here, then go back. So change the env file for the backend. So here it is. Save it now. Well, now we can start the backend. Node beam. Yes, here it is. Sorry. So we've started it. So now we can start the so here it is. Then we've prepared the environment. So what else? So here I can also change here supply chain UI. Well, and now we need to make some updates in the Web3. So here, we need to create the smart contract instance. For that, let us firstly just let us initialize the Web3 firstly. Then we'll provide it here, the instance, and then the contract. So contract, and the contract will be the new Web3 Ethereum contract with its, what's here, ABI and address. And now let us get the ABI and the address. So firstly, the ABI, we know that it is in the config, then supply chain ABI JSON, and secondly, here the address. I also require config, and then from here take address. So it's fine now, and our Web3 is ready. Now we can go to create the action for the orders. Let us go here to the orders, create an action here. So firstly, we need some constants, order creation and order success. Well, now, we're gonna create a function to create order. So we will get the object with title, description, then delivery company address. After that, the customer address. So then we've got the function with dispatch state. So firstly, let us dispatch now that the type that we create. So order creation, and after that, let us get from the state our smart contract. Its state Web3, then contract. So then go to its methods, then get the methods create order, and then execute it with the params title, description, delivery company, and then finally the customer. So, and after that, so when we'll send this transaction, send it from, so let us get from the state the account address, and when we send it, so we'll receive the error on result, and so then we can dispatch the type order creation success, and the transaction is result. So it's fine now. Then I think now, so we can go to create the form. So let us firstly go to the main. Here the menu, add new item. This will be so create order. Then not account, but create order. So the create icon here, and just create. So then we need to import it. So here, import create from the material UI icons, then here create. So maybe it is better to name it as icon, create icon. Yeah, it's fine now. So now let us go to the index here, and here we'll add new route create order, and the component. So the component will be create order component. We'll get it from the views. So let's first import it, and then we'll create it, create order from components, views, there, create order. So then now let us go to the views. Here, create order J6. So, and what do we gonna need here? So let us, I think there will be the same parameters as an account view. So here, instead for the state, instead of the address, we're going to have it here the transaction, and the state will be orders. So let me just, I think we should rename it from from transaction, new order transaction, and here too. And also, if I rename it here, I should rename it in action. So here, not tick, but new order transaction. Then now go back to create order. So here, new order transaction, state orders, order transaction. So okay, state orders. here. So okay, we'll then create order, order transaction, state orders. So so here first, of course, we need to import it to the index. So orders, here get it, orders. Okay, it's fine now. So create order, orders, so not loading, but pending. And not get address, but create order. And here the new order, dispatch, create order, order. It's fine now, we import it. Yes, get, here, get order. So not the action, so let me just remove it, rename it as orders action. So now it's fine. Okay, so here's instead of the account, we're gonna have got create order. So here it is, create order, and here, so create order, then, so now I think, so there is no need in these styles here. And so let us just create this as a function element, const create order, then so then here show, so let us firstly provide so if we, so from the orders we have got not pending, I think here, but orders pending, yes, pending, it is pending, create order, pending, yes. So firstly pending, then new order, so we write order, new order transaction, then pending, then create order function, So now here, so we'll just return so let us just return so if it is now in the creating mode, not creating but pending, we'll return the circular progress. Otherwise, we'll return another component, and then so we'll return the order form. We will need to create it. Form with on submit, create order, and after that, so if new order transaction, then let us return that, so that this order, so order and new order transaction, and otherwise let us just return an empty paragraph. So and now we should, so let us also import the pending, so import the order form from, so we'll create it in the components and the order form. Let me go now to the components, create order form component. So now, we go back to create order. So I've just removed here the with styles, and because we haven't got the styles now, go back to the form. And so to create a form, let us go to the material UI. Material UI next. Then find there in the demo components the text fields. So here, component demos, text fields, just the first one, get it all. Then, so first you will get it all, go back here, so paste it. And now, so we can remove the currencies. So handle change, render, okay. We will need only one component, we can remove all other ones. Now we should rename it from the text field. So from text fields to order form. Yes, it's fine. And now, so now what about the fields? So we're gonna have got the name. So the name will be first one title, label title. So also here, let us remove text fields. This one. So here title, text field. So and then those should be full width. So the title, and then description, delivery company, and the customer. And finally the customer. And here, so handle change, just let us get only the event here, and then get them name value from E, and then set a state to name its value. Well, so now and handle change here, just only a function now. And also we need to here to get so the button, and so first in here classes, and also on submit function. And here the button, let us import it. Import button from the material core button, and in the button what should be here, it's create, and here on click so we'll pass an event, then event prevent default, After that, if on submit, the state. So that's it for the order form. If we'll go back to the browser, just so get to the, yes. Oh yes, so we should also state here. So we have got name, the state name. So just the value, the state title, then description, then here the delivery company, and finally, so delivery company and customer. And here in the state, so title, description, delivery company, and customer. So go back to the web form, account, create order. So here it is. So let us just open the console. So, and in the action, so orders, so when we create an order, it states address, so it's fine. So let me now create an order. So the title books, so the form, just let me see if everything is correct here. Handle change, so cool. Value on change, no margin. And styles, here contents menu. Well, title, so the e-target here. We'll go back now, create order, so now books, dictionary, then, so who create first, let us go here, go to our available accounts, get the first private key, first import, just import it here. This will be, yes, this will be the supplier, then the second one will be the delivery company, and last one is the customer. Go here, so now we can create it. Just let me open the console. Some warnings there, okay, and create. So get state web3 is not a function. Yes, it is not a function. Go back to the orders here. Just let me update it now. Let us try one more time. Books, dictionary, then so second one, and here the delivery company, create. Yes, now we can see that the MetaMask is opening, so we can edit the gas price. So save it and confirm. Well, there it was created. If I will go to Imlab and update it. Oh, this event, and so we now can see that we've created. So here it is. Yes, we've created the form, so now we can interact with our smart contract, with the web UI. and then we will continue to get to connect our web UI to API. Hello everyone, this is the session number 9 of the project How to create a supply chain tab for order account. In this session, we will make some changes with the backend part, and after that, we will finish with the web UI. So firstly, let us return to the back part. And here, so previously, what we were doing, we just subscribe to all the events, and then we go to them, and then we save this event to the database. And now, so in the UI, we want to see not the events, we want to see orders. And for this, so let us just subscribe not for all events, but for order creation events. So in this case, we'll subscribe only when the order was created. We'll get this event and we'll create in our database new order, and using it, so we can request the orders of any member. Well, of course, we can subscribe to other events, and I want to remove them from the smart contract. And to get the information about the time when the status was changed. So, but let us firstly just not get the whole history of each order. Let us firstly just get just to get the event when the order was created, and store information about member orders. And so so for this, well, for this case, let us change these lines of code. So we contract events, then we need to, so not for all events, but for order created, and then the order will be created, we'll subscribe to it. So let us first not remove the log here, and so, and then let us change the model. Now instead of the event, let us rename it as an order, and we won't save the status, just only the addresses of different members, and rename it from the event to order. Of course, if you want, you can then just try and just practice to store the whole the transaction history, but here we just will store only the orders. So now we got the order. Let us also rename it, so order.js, and go back to app. And now, so here instead, so firstly not event here, but order, and go to the index here, and here also order. Back to the app, order, model order. So, and here firstly let us rename from the events to orders, and the same will provide their address, and remove not events but orders, and entity order. Well, it's fine. And so if also I would like to change here, add the regex. So here is final, and now here order created from block this. Let us firstly, so order create, no status now, move these, just event return values. Well, it's fine now. So let me save it. And now, so firstly, so to test it, let me go to the console. Here I am now so for this, firstly, I need to go to the Ethereum, then also firstly I need to start the Ganesh. So it's already started, so let me stop it firstly. So okay, see, so Ganesh. So I just need to get these accounts. I will copy them. So let me just store them here, then go back. So now I will need to migrate them. So truffle migrate. So here's the smart contract address. Let me just copy it, go to the init file, and so change here. So and now let me go to the mlab and delete all documents in the previous collection, and not on so let me just mlab, my databases. So the supply chain project. So some collection, delete all collections now. And now, so return back. So now we're gonna have got a new, so and here, water schema. So it's fine now, I think. Now we can start. So to start it, currently there are no events there. So, and well, so let me now stop it firstly. So, and we'll interact with our UI, web UI. So, and for this, I would like to install the package course. That sometimes when we interact with the API, the course error can come, so we're not to counter it. So let me for this install this package and use this for the Express API. So course, and here I just need app use course. So now it's fine, and I think that's all for. So let us just try it. Start using Nodemon. Then, so let me go here, and now so create new window, go to the desktop, to the supply chain UI, then here go to the source, then to the config, and here in the index, so here React new now I need to go, so let me go back here, so go to end file, take the new contract address and provide it here. So if I run npm run start, oh, maybe I'm not in them, so let me go to the, so here, from here, the app, the index, and now, so npm run start, so here's now the address, so let me go to the MetaMask, so now let me just change to the localhost. Well, let me go to take the first account, go back, import it here. So now I got it. So is it this account? Yes, it is. And now I can just create order, then delivery company, the customer, create it, confirm it, wait, so we can see the hash. So if I'll go to imlab, update it now. So now we can see the orders here. If I'll go here back, so here you can see that now we're subscribing to this event. And so for this case, now there is no need in this log, which I already tested it. So let me not remove the error, but remove this one. And well, now our back part is ready. Well, now let us continue with the web UI. So firstly, let us go to the main container. And now here, so we need to create one more menu item to have good link inside it for the orders list. So let's do it, orders here, and here all the orders. Well, and now let us go to the index and add here new route. So the path is orders, and the component which will be here. So we will need to create it. It will be just orders. Well, and we will import it from the, so import orders from components, views, orders. Well, now we need to reduce. So firstly, let us go to the constants and create two new constants. They are order, so orders root, and the second one is orders root success. Well, now let's go to the reducer, to the orders. Well, and here we need, so firstly, let us import these constants. Then, so in the default state, what do we gonna have? Orders here and loading by default false. So, and well, then, so orders load when we'll start loading it. So we should change the state and assign to the state that currently loading true. And then order load success. So here state, and then we'll get orders. And then here, so assign that to the state that orders and loading false now. So when can we change the location, so we can also, so no, there is no need to clean the orders. So here's loading. So the reducer is ready now. Then let us now create firstly the view. Auto.js6. Not to implement all of it, let us just copy the accounts view, paste it here, then rename from account to orders. So in which case, well, it's fine now. And when you component mount here, we'll get orders. And so this from the props, then classes, not address here, but orders. Well, first let's go here. So and where's this account? Yes, and create order. So here there was a warning that there's no need in this. So go back to order. Now here, so we'll need the action, not get address, but so get orders, actions, orders. Well, we'll create it. Then what about the state? The state here we're going to have the order, orders, and get it. Well, so orders, then state, or state orders, and loading from orders. Then here, instead of get address, get orders. So and here, get orders. Then, so here, so currently if loading, then circular progress. And well, if orders, then let's ask, instead of this, we'll create a new, so component, orders, order list component, and they will provide the array with orders. So now I can see it's fine. Well, so after that, so firstly let us create this component. Go to the component here, create file order list j6. So and to get it, let us go to the material UI. Then to the demos, and there we should go to lists. Here it is, lists. Well, here there are different lists. Let us go to lists. this one. So maybe not this one, maybe some, so can take something else. So, or maybe, okay, let it be this one. Show the source, then copy it. Go back here. So in here, so instead of this, so function, so let me rename it to order list. Then from here we'll get not only classes, so from the props also we'll get orders. So here, so let's adjust first get this component, and then when we'll find, we'll provide here the order. So order list, and here order list. So now first let us, so we'll need to work with the API. So let me go to the lib here and API, prepared file. So into this, so if I'll go to the config and here React app API, so we'll connect with the local host. So HTTP localhost 8080 and go back to API. Here we will connect with it. We will not need the authorization. Well, and now we can implement the method to get orders. And here we will need the address. So the path name is orders and the parameter address. Now we will get it. So it's fine now, we've updated the API. Let us now create, so go back to the order section, and now we need just to create here a new action, get orders, which will return the sync function. So first when we try it, so let us return, so we're also going, so that's the orders load. Then so also I think we'll need to import API from lib app API. So here constant, well, orders, then await API, get orders, and so there we need first to go to the state, get accounts, and get the address. Well, and now so we can dispatch the type orders row success and orders. So and when we're gonna got it, so let us just first check it, go to the order list. So here when we will get the orders, so we can just some changes const and get it from the constant. So now here, let us just return it and look the orders. So, and it's fine now. So let us start it. So, well, run npm run start. So, and then so while we started, so let us go to our mlab, clear it. So it was cleared. Go now to, well, to the backend, start up the backend part. So node bin www.js. It was started. So we've created one order. So that's why now we can see it in the collection. So go back to React app. So some problems with the view. So the source index, no orders. Well, just let us rename it. Orders here, and order, we just need to import also the order list. Import save it. So in the create order, prop types then. So now everything should be fine. This account and order, so let us just change the icon here. Go to the main menu, not create icon, but let us check the list icon. Yes, we can put it. So now we're gonna have here the list icon. List icon. So account, create order. What about orders? So it's created. So orders. So when the component mount, when we mount it, so let us see what do we have. So orders, component these probes get orders. So in here, dispatch to get orders. API here, so no orders here, so I'll go back to the index. So here's component. So let me just, there was a little mistake here. So now go back to orders. Yes, and we can see it appear and here. So we can see that we got this order from the API. So let me go back now, go to orders, then here go to the order list. And now let me just remove the lock here. Well, and now, so let us prepare it now instead of this. So here we're gonna have the orders. So we will map them, then we will get, so firstly, well, the order, then we've got the order, then this section. So here, order index. So and then there is no need in this. So in this I can also remove. Well, and then so here the order, also the order index, and the item. So not item, order. Well, order index. So if I will save it now, so let me just remove this, save it, go back to the browser, orders. So here it is, order and its index. So and now, so we got the order, but we got its index. And now let us get, so change a little bit the action to get, so to get all the information about this order from the smart contract. So for this, we need to get a smart contract from the state the 3 contract. Then so we will change the orders object. So we'll, for each order, well, we'll get this order. We will go to the smart contract and execute its call method, get order by its index. So order index, and then just call it. So and it should be not a constant, and that's it. So and then we're gonna get it. So go then, let us just change the order list now. So now we have got, so not only map order, and let us just map over the order and the index, section index, order index, then here, so let it be order, the title of the order. And well, if we want to push on it, so just click it, on click. Well, first we need to import the history and the object from the state, so using which we can switch different routes. So history from store index. Well, now on click, well, let us history, so on click history, so where is it? Yes, it's here. So on click, not here, on click history push, and we should bind it the history object, and we should, where should we go? So let us go to orders and then its index. So that's it. And when after that we should go to the index, and here let us add new route, index, the route orders, and index. Well, and the component to be not orders but order view. So we'll create it, import order view from components, views order. Then if we will go to the views, now here let us create it, order view JS6. Then let us just copy the orders and make some changes here. So now what about the state? We need orders, then not only state, we will need the index of this page. So it's named by own properties, own props. From the own props, let us get the index, own props params index. Then we'll get orders, no need in loading currently, and get orders. So, well, what's next? So no need in this, no need in this too. So orders index. So in here, no loading now. No, this now. Well, here, so what should we see? Let us import the typography. Well, and here, so not order list, bar card content. Well, and here, so let me just go to account. So here's typography, copy it. So now we have got, so let us take this order. And here, so what about the typography? So here instead the address, let us now firstly, as I remember, order 0 is the title, then order 1 is the description, and order 5 is its status as a number. So let me save it now. So canvas of orders. So if I go back to index now, order view. Order view. So components, views. Now it should be fine. If I'll go back to the browser, go to the orders. So country property gets order by order index. So let me just go back to the action, orders, and here, so methods, I think, methods get order. Let me now return back, go to orders. Well, some problems with it now. Orders, maybe it is empty, but I don't think so. Collection, there is one inside it. So order index, orders. I will return to order list, and here find, so orders map. So there is an error here. So, and if I'll go back, so I think the problem in action. So because promise all, we should wait for it. Now let us update it. Go back now. Orders. So, but undefined now. So let me go to the order view. So firstly to the order list. Then here. So what's here? So here order index. So just on the index. Then order index order, not title, but the 01. So update it. Go back now. Orders. Yes, orders here. Click on it. So we can see books dictionary and its status as a numeric. So you can see it now. We connected our web UI, so we can create orders, and it will create so the order and events, and our backend will get it. And after that, we can go to the orders and find any orders associated with this account. So the web UI view list is ready. And well, now let us create the functionality. So we can start deleting this order, then we can stop it, accept. Well, for this, let us go back to the code. First, we need to create some new constants. Well, in the action. So of course we can create different constants for different actions, but now let us just create constants for or any action with the order. Firstly, and the second one when the action was successfully passed. Success. Well, then we should go to the reducer, to the orders reducer, and there, so we should add these two actions. So the first one, order action. So we're gonna have the state, and so we update. So let us create state with updating. So true. Well, and the second one. So the second one is order action success, and there let us just here assign it the state. Well, then updating false. Well, and for this, here we need to create updating false. Now we need to create the actions for smart contract actions. So let's go here. So the first one will be, so we've already created the action to create the order. Now we can create the action to start delivering order, or just start delivering. Let us simplify the name. So index, we'll get in the order index here, and then we'll return the async dispatch get state. Then let us firstly dispatch that now we have some action with it, and after that we need to execute the smart contract action. We have 3 contract, well then methods, well then start delivering order by its index, well then send. So from there, let me just copy it. So the send from, so let me copy just this firstly. Well, send from, then error result, then we should dispatch that the order action success. Order action success. And that's it. So let me see now these parameters. Maybe we'll need them to then. So start delivering, then nearly the same will be to stop delivering. So stop here instead of the start. So stop delivering order. Then the next one will be when I want to accept. Accept. And the last one to when we want to decline. Well, now the actions are ready. So, and we need to now go to the order view and update it. So, and what do we need here? So firstly, we will need the button. So let us import the button. Then after that, let us go here, card content. Well, card content, then let us create it after it. So, well, so we have got the order. And so if the order status is 0, so in this case we will and the order, so and the current account. So let us first change some things here. So index orders, then the current account, so state account address. Well, also we need that updating. Yes, updating state orders, updating. So in the dispatch we need, so start delivering when I have got the index, and then we dispatch it and use start delivering. Let me import this function. So, well, I will need to import not only start delivering but all other ones. So they are stop delivering, accept, and finally decline. Go back, start delivering, then let me just copy and rename start delivering, stop delivering, then here accept, and finally decline. Now I have got all of them, so go back here and here in proc, so it's index, then what do we gonna need? Account updating. What else? Start, so all the actions, start delivering, stop delivering, accept and decline. So firstly some properties, then actions. So now here the if, so and if the order is equal to account, well, in this case let me create a button. In the button, so start delivering, and then here on click it. So on click I first have the event, so in here firstly let me prevent default, and after that just execute and start delivering by the index. Well, here's the start delivering. This is the condition. So, and what else should be here? So the first button, so then just let's copy this and make some changes. Then what's then? So if the order status is 1, and so to stop delivering, so here we'll stop it, stop delivering, then now we need to accept or decline it. So now if the account for is it, and here's so, and the button will be. So let me just create it for the accept, and we'll check it, and the same one we can create it for decline. So we can just create one more button here. So in other case, just empty paragraph. So in here on create start, so accept. Here it is. Let me just save it firstly. Then what can I see? So everything is fine. Go back here. So counts. So go, if I go to orders, I can see it. So, and currently I'm with the supplier account, so I can't see any buttons. I just can see some information about it. Now let me go to my list with accounts, get the private key of the delivery company. Now here I will just import this account, import it. So here it is, check it. It's fine. I need just not only check it here, I need also to update the state. So go back to the orders. I can see the order, click on it. Oh, you can see start delivering. So let me just start delivering it. I will click here, go here. So some parameters, just maybe we can set one here, confirm it. Oh, success. So file will update now. I can see that status changed. So now I can stop delivering it. So let me do it. Just stop delivering, confirm it. Orders just to update. So I can see now it's the second. Well, and now I can see the buttons. So in this case, I need to now import the private key of the customer. Just import it. I can see it now. Accounts. So here it is. Orders. Order 0, and I can accept it, as you see. Just let me do it. Accept. So some problems. So I know why this happened. So I need to go to the orders, and here instead of the accept, I need to just type accept order and decline order. Save it now. Go back. Count orders. Order 0. Accept it. Yes, I can see it. Confirm. If I go to orders, oh, so here I can see that it was accepted. So now I think our web UI is ready. We can, of course, we can just add here some more beautiful views, add validating here for the form, so not to pass incorrect parameters so in the order. So we can also create something more beautiful. We can update this after each action. And what else? Of course, also we can make some optimization with the smart contract. We can emit locks when we make actions which is not a great order. We can there emit only the index. Well, but I can say that the supply chain dApp is ready. So we've created the smart contract, we've created this truffle project to test it and to migrate. Well, what else? We create the backend part to subscribe to the events and to get information about which address, which orders does, which order indexes does he have. And also we create the web UI part, which interact with the smart contract to create actions, and which interact with the API to get the information about the actions. So I can say that the supply chain dApp is ready now.